Good morning, everyone. So let's start. Okay. Yesterday we have done some questions. Okay. So I was not able to send you the PDF of that. Okay. But from now on, after the class, just wait for 2 minutes. I will send directly. Okay. In the chat box only. So let's start with our first question of today. Number of prime numbers less than 10 is P. Okay. And number of composite number less than 15 is Q. Then we have to find P plus Q. Good morning, Sarthak. Good morning, Prajwal. Number of prime number less than 10 is P. Okay. Just start. It's just started. Okay. So number of prime number less than 10 is P. What are the prime number less than P? 2, 3, 5 and 7. So P is equal to how much? P equal to 4. And number of composite number less than 15 is, remove all the prime numbers. That will be 2 removed, 3 removed and 5, 7, 11 and 13. 6 numbers removed. Okay. So how much we got? 9. 7. Okay. Let's count the composite numbers. Okay. So what will the composite numbers here? 7. Very good. Q equal to 7. So 7 plus 4 is equal to 11. Easy question. Can we move on to next one? Number of composite number. Okay. Let's move on to next one. Let P and Q be the natural numbers which are less than or equal to 20 and are prime and composite respectively. Okay. So number of prime numbers less than 20 are, again count. P can be equal to what values? 2, 3, 5, 7, 11, 13, 17 and 19. So 3, 3, 6 to 8. So P value is 8. So what will be Q values? Q values will be equal to 12. Very good, Arush. Very good, very good. So Q values will be equal to 12. So 8 plus 12 is equal to 20. 20 minus 20 will be equal to 0. Okay. Take a screenshot. Later you can see it again. Or I will send a PDF note. No worry today. Okay. Okay. Let's move on to next one. If x and y are the prime numbers that satisfy this equation, what are the value of x and y? Okay. Q is 8 in question number 1. Count it, है ना? Number of composite number less than 15. Okay, okay. No, no, no. Q is not 7 here, na? Why Q is not 7 here? See, it's less than 15 they are saying. Less than 15. Okay. Less than 15. How many composite numbers? So remove all the prime numbers. So 2, 3, 5, 7, 11 and 13. These numbers will be removed. Yes or no? Any prime number I am missing here? I was just checking you. Any prime number we are missing here? 3, 3, 6. 6 prime numbers are here. Okay, 6 composite numbers are here. And 4 prime numbers are below 10. Okay, one should be removed. Okay, one should be removed. But I am just saying these are the prime numbers. These are the prime numbers. Okay, so remove all the prime numbers. So 15 minus 6 will be equal to 9. And we are removing 15 minus 6 is equal to what? 9. Correct? Yes or no? Less than 15. No, no. We have to exclude the 15. We have to exclude 15. So how many number left? 14 only. And 14, all the prime numbers removed. So we got 14 minus 6 is 8. Now we remove 1 also. Correct? So 7. 7 plus 4 will be equal to how much? 11. Understanding? Yes or no? Okay. Let's move to next question. Yeah, this is a very easy question. X and Y are prime numbers which satisfy this equation. In this method, we can just apply. Yeah, in the question number 2, answer will be what? Not 0, 1. Why? Why we have left 1 point here? Less than or equal to 20. So 20 is included here. Correct? Less than or equal to 20. So 20 is included here. Correct? So if we remove all the prime numbers less than 20, Q value is 12 minus 1. That will equal to 11. 12 minus 1 is equal to 11. So 20 minus 8 minus 11 will be equal to 1. Option number A. Very good, Naman. Very good, Devi, Priya. Okay? Understood, everyone? Any doubt, anyone? There is a confusion, I think so. There is a confusion that 1 is composite or not. 1 is not a composite number. 1 is not a composite number. Those who are getting option 2 as answer, they are considering 1 as composite. Yes or no? Yeah, 1 is neither prime nor composite. 1 is neither prime nor composite. Very good. Okay. So answer will be 1, not 0. Remember this thing. Very good. It will start from 4, 4, 6, 8, 9, 10, 12, 14, 16, 18, 20. Very good. So let's move on to next one. Next one is x and prime numbers satisfying x square minus 2y square equal to 1. We can just apply what? Uh, Dhanush, you have left 15 in that. Okay? You have left 15 in that. That's why you are getting that answer. Okay. So we will just satisfy the option. Option A, let's say, option A, x value will be 3. So 3 square minus 2 times 2 square, that is 9 minus 8, which is equal to 1. We don't have to check any of the other options. We directly got 1. Very good. Let's try this one. So we did this type of question yesterday only. We will bring p square here. So q square minus p square equal to 14. Q square minus p square equal to 14. After that, what we will do? Option number E, 4. Okay, very good. A minus B into A plus B. So Q minus P into Q plus P, and we have to find number of integers for which this is true, correct? We can write 14 in how many ways? We can write this as 14 into 1, 1 into 14, 7 into 2, 2 into 7. Now their negative parts also, okay? Negative parts also. Here we don't want values, we just want how many solutions will be there, okay? So just start with the cases. Let's start with the first case. Case number 1 is q minus p is equal to 14 and q plus p is equal to 1. When you will add these two, you will get 15. So q equal to 15 by 2, which is not an integer. So this and this got cancelled. This and this got cancelled. Correct or not? Because in both the cases, I will take this as 1, this as 14. When I will add these two, I will get 15. Okay. Let's check the second option. Let's check the second case here. Case number 2. Q minus P equal to 7. Q plus P is equal to 2. Again, when I will add these two, I will get 9. So Q equal to 9 by 2. Again, this is not an integer. Correct? So again these two cases got cancelled. Same will happen for the negative signs also. Same will happen for the negative sign. Minus 14, minus 1, minus 1, minus 14, minus 7, minus 2. So nothing will come from here. Answer will be 0. Option A is correct. Very good. Is it clear? Yesterday we have done a lot of research on these types of questions. Okay. So let's move on to next one. Total number of prime numbers among the first 20 natural numbers. We have already did that. What is the answer? Tell me in a second. Jiffy, fast. 8. 8. Very good. Very good. So answer is simply 8. There are total 8 prime numbers. Okay. Next question. Among the first 50 natural number, find the number of twin primes. Twin primes were the primes whose difference was 2. Difference between two prime numbers equal to 2 is known as twin prime. Oh, very fast. 6. Can anybody tell what are the 6 twin primes? Okay, I will write. You also write. 3 comma 5, 5 comma 7, 11 comma 13, 17 comma 19. Then what will come? Very good. 29, 31, 29, 31, and 41, 43. So 1, 2, 3, 4, 5, 6. Very good. Very fast answer. Excellent. Excellent job. Very good. Let's move on to next one. Don't worry, you will get the PDF of yesterday's class and today's class. Just this class ends, okay? Yesterday there was some glitch. It was not being sent. It will be sent on this meeting chat only, okay? As the class ends, I will send a PDF, okay? You can download it from there, okay? No hurry to write all these questions. And from tomorrow's class, I will send the homework, okay? 23. 23 is not a twin prime, na? Yeah, at 9:05, exactly at 9 o'clock 5 minutes, you will get the PDF. Not in the group, here only in the chat box. There is an option to send PDF. Okay, our ADP guy was not knowing that, but today he will send it. Okay, no problem. Let's move on to next one. Consider all the following statements. Tell me the answer. I am just giving you a minute to solve it. Priya is too fast, yeah. She said C option. Okay, all prime numbers are odd numbers. This is a false statement. Why? This is a false. 2 is already there. Yes or no? Yes. Kaushik, you will get yesterday's notes also. There are only 5 single digit prime numbers. Correct or wrong? Let's say 2, 3, 5 and 7. We have only 4. This is also wrong. So if first and second are wrong, all these options got wrong. So we are left with only C. We can do it like this also. There are infinitely many prime numbers. Obviously, a prime number has only two factors. That is also a correct statement. Okay. Um, Simha, don't worry. You will get the PDF. Okay. No need to worry about the screenshot and everything. You will get the PDF today. Do the next one. Sum of first 8 prime numbers divided by 7. Oh, 11. Now the competition is increasing. Okay, sum of first 8 prime numbers 2 plus 3 plus 5 plus 7 plus 11 plus 13. 3, 3, 6. Then 17 plus 19 divided by 7. They are asking the same thing. So 5, 10, 17, 28, 41, 58 and 77. 77 upon 7 is equal to 11. Very fast, very good, very good. Yeah, this is looking very good, yeah. This much fun is not in the offline class also because you all are very 56 divided by 7 is 8, but sum is not 56, na? Sum is 77. Sum is 77. Okay, let's do the next one. The average of three consecutive even number is 24. Okay, average of three consecutive even number. Let the even number be x. So next even number, consecutive means one after the another. Another one will be x plus 2 and after that will come x plus 4. So these are the three consecutive even numbers. Okay, and their average is 24. Okay, so we'll get 3x plus 6. 3 multiplied by 24 is 72. So 3x equal to 66. So x equal to 22. So what are the numbers? 22, 24 and 26. So what we need to find? Difference between the largest and the smallest, that is equal to 4. Option C. Yeah, very good, very good, very good. Going at a good pace. Can we move on to next one? Everybody is clear? Three, how three consecutive number? See, in the question they have given three consecutive even number. Consecutive means 2, 4, 6. Three consecutive even number means 2, 4, 6. है ना? Yeah, x plus x will make it as 3x and 2 plus 4 will make it as 6. Understood, Meenakshi? Varun, you got it? In the question they were saying three consecutive even numbers. Okay? Okay, let's move on to the next one. Sir, we can directly write it as 4. Why? How 4? Okay, very good. Very good, very good, very good. That's who said this thing? Harshita, very good. That's a very good approach. X plus 2 and x plus 4. These are the three numbers. So difference between these two will be equal to 4. Excellent, excellent. You will crack J. for sure. Okay, next question. Two consecutive means one after the another. Okay, Ananya, I will send in this only. There are four prime numbers taken in ascending order. The product of first three prime number is 1771. Okay, 1771. I think so. Some student might have done the CBC book directly, so they are telling answer that fast, yeah. But that's good also if they remember the answers. Okay, let everyone solve. Let everyone solve. Okay, so four prime numbers taken in ascending order. So what is prime factorization? And their product is 1771. So what will be their prime factorization? Can anybody tell what will be their prime factorization of 1771? 7, 11, 13. 7, 11, 23. No. Huh. 7, 11, 23. Yeah, some of the questions are CBC book and we will include more. I am just sending you the PDF. Sir is sending you the PDF right now. You can download yesterday's class PDF. Okay. It's in the chat box right now. Okay. For a second, please stop messaging for a second and you can download it. Okay. Everybody got the PDF in chat box. Okay. In this Zoom chat, there is no pin option. So we can't pin the PDF there. Okay. So yesterday's class PDF it is. Sir is sending again. Please stop messaging for 2 minutes. Please everyone. Stop messaging. Let everyone download. Okay. Just 2 minutes. Wait 2 minutes. In this PDF, all classes notes are there. Okay. Physics, chemistry, math, everything. Yesterday's each and every class notes is there. Just download it. Don't message. Don't message. I am again repeating. Let everyone download first. Okay. I am just waiting for 1 minute. It might be that you are not having that PDF app, Shloka. Due to that reason, it's not showing you. Okay. Download some Adobe or something like that. Okay. Okay. Let's move further. Yeah, it's yesterday's class. So 1771, if we will prime factorize it, okay, if it will prime factorize it, it's 7 into 11 into 23. Am I correct? 7, 11 and 23. Am I correct? Yes. So there are four prime numbers taken in ascending order. Okay, the product of first three prime number. Ascending means smallest to largest. So first three prime numbers we got 7, 11 and 23. Sum of last two prime number is 82. So sum of these two equal to 82. So 82 minus 23 is equal to 59. Okay, that is equal to 59. Now, what is the product of last two prime number? So 23 into 59, that is 1357. Very good. That is 1357. Everybody understood this question? Is anyone having doubt in this? Why we have taken first three as 7, 11, 23? Arey beta Karthik, let the class end na, then you will get today's class PDF. How before the class we can get today's class PDF? है ना? Don't be in a hurry. You will get everything here. We are here to give only, not to take anything. Okay? So let's do the next question. Yeah, very good. Find the difference between largest and the smallest four-digit number. 0147. So largest four-digit number will be what? 7410. Now we have to find the smallest four-digit number. Yeah, at the end of the class, again, I will send the PDF. Don't worry, you will get the PDF. Smallest number will be what? It will start with 0 or not? First tell me, can it start from 0? No, very good. Why? Because it will become a three-digit number. Okay, so it will start from 1047. Subtract it. 10 minus 7, 3, 10 minus 4, 6, 3, 6. So our answer is 6363. Correct? Option D. Very good, very good. Everybody understood? It will not start from 0. है ना? Yeah. Let's move on to the next one. No, 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 no. These are not JEE mains question. These are basic level understanding question. JEE main question will be doing in the fourth to fifth class. Okay. These questions are not JEE main. I will not say any false things to you. These are basics only. We will do start doing JEE main question. I will send PDF. Don't worry. At the end of the class, I will send yesterday's PDF also. Okay. Which of the following statement is not correct? Sum of even and odd number is an odd number. That's a correct thing. Sum of even and odd number is an odd number. Sum of two even number is an odd number. That's a wrong. And we got the wrong one. It's very easy. We have done yesterday only. Okay. Too easy for you all. Let's do this one. Okay, Karthik, I will just go again to eighth question. Don't worry. Which question was that? Just tell me the first two words if you remember. Kshitij said 3 is to 5, 9 is to 1. D option is correct. Okay. 9 is to 1, 9 is to 1. Everybody got getting D option only. Okay. So sum of two numbers equal to 20. So sum of two numbers equal to 20. And their difference is, sorry, and their difference is 16. Okay. And their difference is 16. So add these two numbers. So 2x equal to 36. So x equal to 18. Put it here. You will get y equal to 2. So we have to find the ratio. 18 upon 2 is equal to how much? 9 by 1. So option D is the correct one. Correct? Very good. Okay, I think so. You can do this easily. There are four prime numbers written in ascending order. So first three product is given and last three product is given. First three product is 385, last three product is 1001. See, 1001 prime factorization you have to learn by heart. It will be used again and again and again. It is 7 into 11 into 13. 7 into 11 into 13. This is prime factorization of 1001. 7, 11, 13. Okay. So 7, 11, 13. And we need the last number only. So we don't have to check 385. So option B is the correct number. Two numbers prime factorization you have to learn. 7 into 13 is 91. It will be used again and again. 1001 prime factorization is 7, 11 into 13. Another is 5. Okay. Yeah, 5 will come because last digit is 5 only. Correct. Very good. But we don't require that because they have asked about the last digit only. Okay. Can we move on to next one? Okay. Just, I think so. This is the last question of today's. Uh, Siddharth is asking, sir, maths will be hard. Okay, I will come to this question. No problem. Prime. Okay. So A plus B, B, A minus B, A plus B, all are prime numbers. So you have to do hit and trial. Okay. You have to take A, B, A plus B and A minus B. All are prime numbers. Let's say first thing comes in our mind is 2 and 3. So this will become 5, but this will become minus 1. So this we have taken wrong. This is a wrong thing. Then let's take 5 and 3. We take 5 and 3 here. Okay. Where is the eraser? Okay, so 5 and 3. So 5 plus 3 will become 8. So this is not a prime number. So this is also wrong. Okay. So let's think of another number 5 and 2. 5 plus 2 will become 7. 5 minus 2 will become 3. So 5 and 2 are what? Prime numbers only. So everything is correct. So add all these two. 7 plus 7 is 14. 14 plus 3 is 17. Sum of these all numbers is a prime number. Okay. No, only live classes will be there. No recorded lectures will be present. Okay. In Rezo app, we might give the recorded lectures, but for other students who have joined, okay, for them only live classes are there. Okay. Yeah, only trial and method because number of variables are more than number of equation. Rezo app. 15 is not a prime number. Very good. But we got some as what? 17. Okay. So I will just take a minute. Okay. To clear any of your doubts. Okay. Yeah, Resonance e-learning app. So any doubts you are having, you can ask. How can we crack IIT, sir? How can I get notes? From which campus you are, sir? Okay. I am from Himayatnagar campus, Sikandarabad zone. Okay. You can notes again and again. I am repeating after the all classes ending, you will get in the chat box, and after that we will close the chat so everybody can download. Can you reduce the speed of teaching? Yeah, I can reduce, but these questions are very easy. Okay. For the teaching part, I will go very slow. I'm Resonance Guru Campus Potential. Okay, thank you. How to log in Resonance? That you have to contact your campus, whichever you are enrolled in. They will tell you. Okay, sure, sure. I will reduce it. No problem. Every Saturday we will be having test. Yeah. Okay. Okay. No, no, no. See, there was some miscommunication. I was not knowing that. Everyday classes will be uploaded into our YouTube channel. Okay. Resonance e-learning channel is there on YouTube. Okay. You will get the recorded lectures. If you missed any of the lectures, you will get on the Resonance e-learning YouTube channel. Okay. Link. Arey yaar, you don't know how to YouTube. Right? Resonance e-learning. है ना? Do some little bit of hard work, yeah. It's there. You can check right now also, it's there. You can check it. Okay. Sharan, yeah, you can go to Resonance YouTube learn e-learning channel. There will be everything. Every lecture is present there. Okay. Sir, I have a doubt. Yeah, tell me. Yeah, it's there. Thank you. Which IIT is best for student? Any IIT which you get, IIT Hyderabad, it will be near to your home. Okay. Yeah. Link, I will be just posting the link here in chat box also. If somebody is not able to find, you can get it from here chat box. No, no classes of Sunday. Triple IT Hyderabad is far better than IIT Hyderabad, hands down. Yeah, Bala Virat, what you are asking? I missed your message, sorry. Yeah, I am just sending the link. Please see the link in the chat box. Imaginary numbers will come. It will be a part of Bala Virat. Your chat is disabled. Okay. Yeah, send it. I will send Avinash, don't worry. At the end of the class, both the PDF will be sent again and then I will close the chat so that everybody can download. Obviously, IP syllabus and everything will be there. Okay. Let's move forward. Okay. Okay. So let's move forward. Now today's topic is algebraic identities. Okay. Okay, yeah, or you can say algebraic formulas, which we have already learned. Okay, both things are there. So we'll start from very basic and we will go to all the formulas which you have read up to class 10th. Okay, so first formula is we all know a plus b whole square, that is a square plus b square plus 2ab. Second one is a minus b whole square, that is a square plus b square minus 2ab. Correct? Third formula we all know a plus b into a minus b, that is equal to a square minus b square. A plus b into a minus b, that is equal to a square minus b square. Correct? Now comes the important parts. A plus b whole cube. A plus b whole cube has two different formulas. Okay? One which we have already learned in class 8th, 7th also, that is a cube plus b cube plus 3ab into a plus b. Okay, and its another formula is a plus b into a square minus ab plus b square. Okay, like two formulas are there. Like say we have different kind of shoes for going for different events. Like if you are going for football, playing football, you will wear the spikes shoes. Okay, when you are going for playing basketball, you can't wear the spikes shoes on basketball court. So for different places we have different formulas. Okay, both are same. When you will open these two, you will get the same result. Okay, but different condition. Whenever a square b square is given, we will use formula number 5. Whenever a and b is only given, we will use formula number 4. Okay, so let's move on to next formula. A minus b whole cube. A minus b whole cube, that is a cube minus b cube minus 3ab into a minus b. A cube minus b cube minus 3ab into a minus b. Correct? Now for same formula we have a different one. A minus b whole cube, that is a minus b into a square plus ab plus b square. Now many students get confused in formula number 5 and formula number 7 for the signs, है ना? Where is plus sign, where is minus sign? So I will just tell you a basic trick here. Here is a plus b whole cube is there, plus sign will come here, so one negative sign will be here. When a minus b whole cube is here, one minus sign came here, so no another minus sign will be there, only one minus sign per formula when we are writing in terms of brackets. Okay, understood this thing? Fifth one is wrong. Fifth one is okay. Sorry. I have written in that. Oh. Thank you. It's a cube plus b cube. A cube plus b cube. Sorry, some printing error here. Okay, a cube minus b cube. Sorry, by mistake. Big mistake. Sorry. Okay, yeah. Is it clear now? A cube plus b cube. A plus b into a square minus ab plus b square. I was too involved in chat, so I written as some wrong thing here. Okay. Yeah. Yeah, we will do. We will do the test of divisibility and everything, but after this topic because we have to learn this formula properly. Okay. All the 7 formulas are clear. Have you seen all these 7 formulas before that also? I think so. We have seen all the formulas. Okay. Yeah. So let's move on to next one. A plus B plus C whole square. This is equal to A square plus B square plus C square 2 times AB plus BC plus CA. AB plus BC plus CA. Okay. A square plus B square plus C square plus 2AB plus BC plus CA. Now, everybody is done up to this formula, 8th formula. Now we are moving to 9th formula, which is very important. Okay, so let's move on to next formula, 9th one. And this is the most favorite formula of JEE Advance. This formula they are taking from class 8 book, directly from class 8 textbook. We all know this formula, we have seen this, but we never remember this. A cube plus B cube plus C cube minus 3ABC. A cube plus B cube plus C cube minus 3ABC. Show the eighth one, okay. Take a screenshot, Naman. Done? Okay. A cube plus B cube minus plus C cube minus 3ABC. This formula is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus C. A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Okay. What is your doubt here? I must have missed your message. Okay. So one more formula will be there. I will just derive that formula. Okay. So another formula is what? Half of A plus B plus C into A minus B whole square plus B minus C whole square plus C minus A whole square. So we are having two formulas for this. Okay. A cube plus B cube plus C cube minus 3ABC can be written in this format also. Okay. Yeah, Venya, what is your doubt? IIT Hyderabad or okay, every college is good here. Like it will depend upon what rank we are getting. Okay, let's start with the proof. Let's start with the proof. Proofs are important points. Okay, so we are given A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Correct? This was the first formula I have written. Okay. Now what I will do, I will just divide it by 2 and multiply it by 2. I am dividing by 2 and multiplying by 2. So 1, 2 will come here, 2, 2, 2, 2 and 2 again. Because when I will take 2 common, it will be cancelled by the denominator 2. Correct? Yeah, every class will be uploaded in YouTube. Don't worry for that. Okay. So it will be 1 by 2 a plus b plus c. So how can I write 2a square? Can I write 2a square as a square plus a square? How can I write by 2b square? B square plus b square. And again for 2c square, we can write it as c square plus c square. Correct? So b square plus b square, then c square plus c square. C square plus c square minus 2ab minus 2bc minus 2ca. Correct? Yeah. Now I will make combinations here. Okay, just see the combinations here. A square plus b square minus 2ab as one combination. Okay, then b square c square minus 2bc as one combination and a square c square and minus 2ca as one combination. So it will be half of a plus b plus c already written here. Now a square b square minus 2ab will become a minus b whole square. Then b square c square, see here, b square c square minus 2bc will become b minus c whole square and left out part c square a square 2ca, that is c minus a whole square. So we derived the formula. Okay. So this is the formula for a cube plus b cube plus c cube minus 3abc. Correct? Okay. So why we are doing this derivation? Why we are doing this derivation? Let's move on to that part. So we got the formula as a cube plus b cube plus c cube minus 3abc as half of a plus b plus c into a minus b whole square, b minus c whole square and c minus a whole square. We got this formula. Okay, correct? Okay. So two cases arises here. Two cases arises here. If a plus b plus c is equal to 0 or a equal to b equal to c. See, if a plus b plus c is equal to 0, if this point is 0, if this thing is 0, then whole thing will become 0. Yes or no? So we can say that a cube plus b cube plus c cube will be equal to 3abc. Then a cube plus b cube plus c cube will be equal to 3abc. All the proving we have done for just knowing this identity, this relation. That is, if a plus b plus c is equal to 0 or a cube plus a equal to b equal to c. Any of the two cases are b whole square plus b minus c whole square plus c minus a whole square. Okay. So two things you have to remember. If a plus b plus c is equal to 0 or a is equal to b equal to c, then always a cube plus b cube plus c cube will be equal to 3abc. है ना?
Good morning, everyone. Welcome once again in the physics session. Before we begin, let me just tell you that yesterday's lectures have been uploaded on our YouTube channel of Resonance eLearning. If you missed them or if you want to go through them again, they are available there. You can watch them. And the PDF of the content of yesterday's lecture will be shared here in the PDF form in your chat box. And the same thing will be carried on in the coming days. Today's lecture PDF will be shared after the class and the lectures will be simultaneously uploaded after it. Alright, so just keeping you in the loop for this process so that you can take use of it as and when required. Fine. So let's continue from where we left yesterday. We were discussing about the physical quantities and the way we were representing them. I said that most of the situations we go with three different types of possibilities. Oh. Number one, I said that maybe a quantity is expressed as a number, or it can be a number into unit, or it could have been a number into unit into some unit vector. So, these were our three different representation methods. Now let me tell you that this vector representation in which I told you what I cap is, what j cap is, we will study this thing in detail when the chapter vector comes in the sequence. Alright, so that would come a little late, and right now we'll be emphasizing on this representation, so that if I say a physical quantity is expressed as a n into u, right? Now let's continue from here. When you write any physical quantity as n into u, you actually mean that this is like an algebraic product. You are multiplying a number and a unit. So you should look at this expression as a product of number multiplied by a unit. All right. So, for example, if I say that the length of some line segment is 4 centimeter. So now this 4 is the number and centimeter is the unit. Okay. I want that you people should look it as 4 times of 1 centimeter. This 4 centimeter should be seen as a 4 into 1 centimeter. So when I say 4 into 1 centimeter, I am explicitly making it clear that the distance which I am talking about is 4 times of 1 centimeter. Now anybody would be able to understand this magnitude of the length if he or she understand what 1 centimeter is, right? You should know the unit first, then only it can make sense for you. So centimeter is a common unit. We know 1 centimeter is somewhat this big. So 4 centimeter may be somewhat like this. So even without the actual measurement, you can have a broad assessment of the size of the physical quantity. If I say it is 4 centimeter, it will be this big. If I say it was 4 inch, maybe it is somewhat like this big. If I say it is 4 feet, maybe it is as big as the span of my two hands. So once you know the unit, you get the chance to assess the magnitude. Okay, so yes, this is the benefit of using the unit. Hi Naman, yes, type your doubt. What doubt you have? Type it. So I was saying that the unit helps us to identify the physical quantity and also helps us to assess the magnitude of it. How big that physical quantity or how small that physical quantity is, even that type of assessment you can get through it. All right. And yes, I'm sure all of us know that a physical quantity can be represented in different units. For example, I can say that 10 meter per second is equal to 36 kilometer per hour. I hope you people might be learning this result, conversion of meter per second into kilometer per hour. Or even go with a simpler one. If I simply say 1 meter is equal to 100 centimeter, or if I say 1 centimeter is equal to 10 millimeter. So you can see that for the distance I have used the unit of centimeter, meter, millimeter. So yes, we can be having these different units for a given physical quantity. But remember one thing, if there is a fixed physical quantity given to you, then by changing the system of unit, you can't change the magnitude of the physical quantity. Okay, I mean that when I write 1 centimeter or when I write 10 millimeter, they represent the very same distance. Why? Because if you see that centimeter to millimeter conversion, if you look at it, you will feel that we are converting a bigger unit into a smaller unit, right? I hope you all know that this 10 millimeter is equal to 1 centimeter. So certainly millimeter is smaller. So you can see that when centimeter is converted to millimeter, if I ask you, have you converted into a smaller unit or a bigger unit? You should say smaller because millimeter is smaller than the centimeter. So if you write 1 centimeter as 10 millimeter, you will certainly say that yes, we have made the unit small. And now see, when the unit becomes small, the number becomes large, right? So in general, whenever you write this Q is N into U, you can say that N into U may be constant if you are talking about a specific physical quantity, about a fixed magnitude. So when I say N into U is constant, you can always make a conclusion from here that n will be inversely proportional to the unit involved. N proportional to 1 by u. When I write it in this form, I want to convey that these two physical quantities are inversely proportional to each other. What does it mean? It means that if u becomes 10 times, n will become 1/10. If u become 1/5, n will become 5 times. So this is a simple conclusion which we can make from this type of inverse proportionality representation. So if you look at this, 1 meter is equal to 100 centimeter. Now we know that centimeter is 100 times smaller than the meter. 1 centimeter is this much, 1 meter is this much, right? So centimeter is 100 times smaller. So when I convert 1 meter to 100 centimeter, you can see the unit got smaller, but the number got bigger, right? So if n increases, u decreases, what is q? Okay, q is the symbol I am using for any physical quantity. See, in physics or in chemistry, maths, whenever we would like to talk about something in general, we prefer to go with a general expression. We prefer to take any alphabet which represents a general situation. So if I am saying something which is applicable on length, speed, force, everything, I mean, it's a common idea which I am saying. So I am using the Q as a symbol for any physical quantity. So Q can be a length, Q can be a force, anything. Okay. Someone asked that yesterday there was J cap also. Yes, correct. Yesterday I was telling you what I cap and J cap is, but we are not continuing that today because I told you that vector approach will be taken exclusively when we go with the vector analysis, and that will be done later. We can't do it so quickly. Before vectors, we have to go through few more things, then the vectors will come. So let's just take a break. That was just like a quick introduction for you people that while expressing a physical quantity, you may need the vector representation also. So my purpose of telling you that I cap and J cap was only to make you aware that expressions for any physical quantity may include those vector notations also. Fine. So this is another aspect of unit that if you change the system of unit, the number and the unit will change with inverse variation. If you make one thing double, the second thing will become half. Okay. Now see, there is one term what we call as the unit, and then there is one term we call as a system of units. Okay, what do we mean by system of units? See, if you talk only about one physical quantity, suppose we are doing a meeting and I say that let's all decide that for the distance we will be using the unit of a meter, and by chance suppose you people also agree. So we decide that okay, now length will be measured in meters. Okay, but if I don't talk about the other physical quantities, then maybe when suppose all of us again disperse after the meeting and we go into our different fields, for length we are on a common page, but for the mass, for the time, for the temperature, if suppose different people are using different units, then it will become a confusion, right? Of course, the units tell us about the magnitude, but the units should be accepted globally also. If suppose in India we had refused, okay, no, we won't listen to the SI system. We don't accept what is meter, we don't accept what is kg, we have our own system. Most of the places had their own measuring system of units. Abhinav, I cap is a unit vector along x-axis. So if I put I cap along with anything, I mean to say that that thing has a direction about positive x-axis. Okay? Yeah. So I'm saying that the units will become effective only when there is a global acceptance. And on the other hand, it is a fact that different places had their different units. Got it? I mean to say that in British zone, those people were using feet for the measurement of distance, pound for the measurement of mass. In our India, you people might have heard some older our local unit system. We define mass in tola. आप लोगों ने सुना होगा ना, गोल्ड और सिल्वर के रेट्स फ्लक्चुएट करते हैं, तो जिस यूनिट में बात होती है, वी टॉक के गोल्ड इज 1,40,000 per tola. In India, we use the tola system, which is close to 10 grams, right? So we have a system of unit in which we use tola, or there are some units in which mass is measured in man also. 100 kg is taken as man. For distance, we had the units of some kos or yojan. So we had different units of our own. But when it comes to a global acceptance, then people have to agree on to those lines which makes more logical conclusions. So yes, Westerners, Europeans and Americans, they came up with a homogeneous system of unit. When I say a homogeneous system of unit, I mean it was decided that we should accept the unit not only for one physical quantity, for most of these fundamental quantities. When I say fundamental quantities, means these basics ones: mass, length, time, something like that. I will explain that later on, what are these fundamental quantities, but still, it was decided that for these fundamental quantities, let us fix up which units to be taken so that it avoids confusion. So people agreed to that because yes, it would lead to smoothness and a better communication amongst different part of the world. So when I say a system of unit, it actually means that it is the acceptance of the units of the fundamental quantities which we will use to describe any other physical quantity. What do I mean? In the beginning, it was considered that only mass, length, and the time are the fundamental ones. Okay. In some late 1800s, this was the notion that mass, length, the time, these are the fundamental quantities, and remaining everything is derived. So now, since there were only three things which were fundamental, so the units for those three were taken, and accordingly, we had a unit called CGS, system of unit. So when I say CGS, what do I mean? I mean that distance will be measured in centimeter, mass will be measured in grams, and the time will be measured in seconds. So people agreed to it, and it became an accepted system. But later on, people realized that the units involved are very small, and the numbers which we get for most of the quantities are very large. So that's why they came up कि यार थोड़ा इसको बढ़ाओ, तो units के base को बड़ा किया जाए. So then came the system of unit of MKS. Now M stands for meter, K stands for kg, and time still stands for seconds. Okay, so there was a CGS system, there is an MKS system. Now Britishers adopted their own system. They called that as a FPS system. F stands for foot, P stands for pound, and the time taken in seconds. So when we say a system of unit, we actually mean the acceptance of the unit of these fundamental quantities so that the other quantities can also be expressed in them. What I mean to say, in the CGS system, if I have to write the unit of mass, of course, I will say something like 5 grams. And in the CGS system, if I speak about the speed of a body, then I'll speak up like this, 6 centimeter per second. So I will say 6 centimeter per second is the CGS unit of speed. And if I convert the same 6 centimeter into 0.06 meter per second, I will say I have converted a certain speed from CGS system to MKS system. Okay, so that's how this system of unit works. People globally accept one standard of the unit and they start following them. It makes sense because when you read the books written by foreign authors, those physical quantities should make equal sense for you, right? So these are the most common ones before SI system. I can say these were the historical names, CGS, MKS, FPS. Now, currently, presently, we are using SI system of units. So, since late 19th century, this SI system came into effect. There was international body of weights and measures somewhere in the France. So late back then, as early as 150 years from now, people from different parts of the world, they met, they agreed, they had a lot of discussions, and somehow in the end they came up with the agreement on few core things, few more important things. What were those? Number one, the number of fundamental quantities were not anymore taken as 3, now they were taken as a 7. So they decided that let there be 7 fundamental quantities, and for all those fundamental quantities, some specific units were adopted. All right. Now, in that SI system, the mass was still taken in kg, length was still taken in meters, and time was still taken in seconds. So that way you can see that it is resembling the MKS. But the only thing is that we are adding few more physical quantities to that, and that's why sometimes we say that SI system is actually a rationalized MKS system. We say that SI system is a rationalized MKS. Now, for rationalized, you people can take it like some updated version, some new version of MKS in which only there were something being added. Nothing was being changed from their prior values. Only 4 new physical quantities were being added and they were accepted like the fundamental quantities. So now today, as per this SI system, globally this SI system is followed now. Now, as per this SI system, all the physical quantities which we come across, they are broadly divided into 3 categories. Okay, SI system asks us to divide all the physical quantities into 3 categories. One of them is called the fundamental, or we also call them as the basic quantities. Second one is called supplementary fundamental. Supplementary fundamental. And the third one is called as the derived quantities. If I'm not wrong, you people would have read this classification somewhere in class 9 also. In chemistry, not even in physics. In chemistry, I think this description is there. I remember about the CBSE text, I don't remember about the other ones, but somewhere I'm sure you would have heard these words: fundamental quantities, supplementary fundamental, and the derived quantities. Okay, so which are these fundamental, supplementary, and derived? Let's take them one by one. When I speak about the basic or the fundamental quantities, They are 7 in number: mass, length, time, electric current, temperature, luminous intensity, and amount of any matter or substance. This amount of matter is that which we measure in the moles. If you remember about the gas, we count the number of particles in the moles. So when we say the amount of matter, this is actually that relation between the mass and the number of particles involved. So see, these are the 7 physical quantities which have been accepted by SI system, and now we follow it globally. These 7 quantities are called as the fundamental or the basic quantities. Not only 7 quantities have been decided, we also have decided that what shall be their units. So for mass, the SI system unit is kg. For length, it is meter. For time, it is seconds. For electric current, it is ampere. For temperature, it is Kelvin. For luminous intensity, it is candela. And for the amount of matter, it is mole. Okay. So 7 quantities and their 7 units. And also we choose some symbols to be used for them. For mass, I will be using the capital M. For the length, capital L. Time, capital T. For electric current, either the symbol I is taken or sometimes the symbol A is also taken. A is for ampere. Ampere is a unit of current, so sometimes this symbol is also used. For temperature, the symbol used is either K or sometimes theta, the same symbol what we use for the angle. Okay, now why I am telling you the symbols of these 5 physical quantities? Because in the next topic of dimensional analysis, we will be needing these symbols, right? So see, I have right now not written for a luminous intensity and amount of matter. Okay, let me write that. This luminous intensity is also expressed by I. Now, since current can also be I, this can also be I, so let me call it I naught just to differentiate it. And the amount of substance is either represented by N, or sometimes we use this Greek alphabet of mu, right? Now the question comes, why are these quantities called uh, fundamental and why not the others? What about the sound? It has a unit too and it can be measured. Sanjay, you are right. Sound can be measured. Sound is a physical quantity, but we don't treat the sound as a basic quantity. Okay? You can see these are the basic ones. Let's first understand what is the criteria to call them basic. Why only these 7 physical quantities are here? Why no other? Varun, no, it's not about the daily use. It's basically their nature of existence. These are those physical quantities who do not depend on any other physical quantity for their existence or for their definition. Okay? Uh, yeah, I'll tell you what luminous intensity is. Firstly, let's understand this. These 7 things are called fundamental because they do not depend on any other physical quantity for their existence, definition, expression, whatever you call. Let me give you an example. Suppose I ask you to explain me what is the speed. If I ask you to explain me speed, you will say, okay, if you travel a distance d in a time t, then the rate at which you are traveling the distance is called a speed or velocity, whatever you are calling it. Now, my question is, can we understand the physical quantity called velocity without talking about the distance and the time both? Can you do this thing? Can you explain me speed without using any hint of the word time? If I travel more distance, does it mean that my speed is very large? No, I might have taken a long time to travel. If I travel for a very large time, does it mean my speed is large? No. So if you speak about the speed, you have to talk about the distance and you have to talk about the time. So that's why I will say speed is not a fundamental quantity, because for the speed to exist, you have to have distance and time also existing. And speed is dependent on both of them. But now, if I change my question, I ask you, what is distance? Or I simply say you define distance. My first question was define speed, and now my second question is define distance. So the speed is defined like this. Now question comes, how will you define the distance? Try to define distance, and I don't think you'll succeed. I don't think you'll succeed. You can give me a formula for the distance. I agree with that. Few people are writing that if velocity is distance upon time, then mathematically distance is velocity into time, right? But is it the definition of this distance? Is a speed necessary for a distance to exist? If I'm holding a pen in my hand, the tip of this pen, the two ends of this pen, there is a certain separation between them, right? Now, if I have to measure this distance, do somebody need to travel along it? Is it a necessity that somebody has to travel? You measure the distance, you measure the time, then only you can talk about the distance? No. Distance will still exist only if nobody is traveling. I simply mark these 2 points on the board. Now tell me, isn't there any distance between these 2 points? Nobody is traveling between these 2 points, still the distance exists, right? So, yes, some answers are coming. Distance is the length traveled, actual path traveled, distance. Fine. Uh, think a little deep. Are you explaining the distance or are you simply using some synonyms? Explanation is something else and the synonyms are something else. So, yes, if you say it is the gap between the 2 points. So, my question is now, what is gap? You say separation between 2 points. What is separation? Aren't these all almost synonymous? The separation, the straight line distance, the path traveled, aren't they all just the synonyms of the distance? You can't define distance. You can't define the separation between 2 points. Ahmed, you're saying total path covered. So my question becomes now, what is the path? Right? How will you define the word path? So you can only go with the synonyms, and then you can't define what it is. Can we define what the time is? I'm giving you another example. Can we define what time is? Our speed was defined as distance upon time. I said the speed depends on distance and time, but the distance does not depend on the speed and time. Now my question is, uh, can we define time? See, again, we are having the formulas: distance upon speed, interval between the two events. Now, how will you define that interval? The period between the 2 points. Yes, I'm getting many answers. Good, it's a very good thing you're trying. But think coolly. You will realize that you are only giving me synonyms. You are using different words for one single thing. Interval is equal to time taken. So my question is, what is time? So you say time is interval. And then I say, what is interval? You again say it is time taken. So is it explanation or is it just a circling of the terms? Time is the continuous, irreversible progression of existence, event change moving from the past through the present into the future. Tremendous definition, my dear. Progression of existence moving past into the future. And then the question comes, how do you go from this past to the future? How do you do that? Right? Even when Einstein was asked what is time, why was Einstein asked? Because actually Einstein created, uh, what can we say, a big mess over the existing notion of the time. Before Einstein, everybody was having the opinion that time is going at a certain rate. Time proceeds at a certain rate. Okay, we can't define it, we accept our inability, but at least everybody was thinking in the way, okay, all the clocks should move in a certain way and the time measured everywhere should be same. Einstein created a big mess. He said that time is not same for everybody. So maybe you people have would heard it somewhere. There is a term called the time dilation. Time dilation. If you are close to the earth, if you are away from earth, if you are close to the sun, you are away from sun, you are close to a black hole or you are away from a black hole, the time proceeds at a different rate. So time is not as simple or as we think about it. There is a lot more into it. So when Einstein was asked, okay, you have done so much on the time, what is time? How will you define time? Einstein said, time is what the clock shows. जो घड़ी दिखा रही है वो टाइम है, वो वक्त है. And indirectly Einstein was also saying the same thing. In the conventional sense, when we define something, you can't define time. And time is a irreversible progression. That is an adjective, right, beta? You are telling me one property of time, but we are not defining time. Let's understand one thing. There is one aspect of what I can say using the synonym, and second thing is telling some property of it. If I ask to define mass and your answer is mass is that property which gives rise to inertia. Correct. Mass is that property which gives rise to inertia. But am I defining the mass or am I just telling an effect of mass? That if a body has mass, then it will have inertia. Got it? So when I say mass is that property by virtue of which a body gets inertia, so this is not the definition of mass, this is one of the outcomes of it. If a body has a mass, then it will have inertia. So we are just pointing out a relation between the inertia and the mass. We are not actually defining it. So, in a way, these seven quantities which have been accepted as the fundamental, in all of them, almost all of them, you can't define them, you can only measure them. Okay, there is just one exception here, that electric current can be defined and still it is taken as a part of the fundamental quantity. Let's go back to the list. Yeah, see, Only this one entry seems like an exception, that electric current can be defined as the rate of flow of charge, right? Rate of flow of charge. That's how we can define the current. So accordingly, electric current should not have been taken as the fundamental, rather charge should have been taken. Why? Because the current will depend on the charge. Charge will not depend on the current. If charge flows, there is a current. If there is no current, the charge will be still there. Right? So, as per the statement, what I am saying right now, that only those physical quantities should be taken as fundamental which can't be defined, which don't depend on others. So, the remaining six obey that description. Current doesn't fit exactly into that, because yes, current can be defined as charge upon time. So there was a reason, there is a reason, that why, even because of the fundamental reason of charge to be taken as fundamental, we took current. This is actually dependent on the application part. Charges don't create magnetic field, electric current creates magnetic field, right? Electric current creates magnetic field, and since in our day-to-day life, magnetic effects are very prominent phenomena happening around us. So that's why, just for the sake of I can say some convenience, the current was taken as the fundamental. So yes, this happens that sometimes we make a rule and then we make an exception for that also, because sometimes those exceptions make the situations easier for us. Got it? So except the current, for remaining things, you can't define them. You can't define mass, length, time, temperature, luminous intensity. Okay, luminous intensity we didn't talk about. Luminous intensity is the measure of the energy which strikes on a surface in a given time on a given area. So this is the measure of energy incident per unit time per unit area. Okay, and when we say the luminous intensity, we actually refer to uh, energy in that region with which our human eyes can perceive them as something like a light source. I hope we people are aware of the fact that light can be infrared, light can be ultraviolet, and light can be visible. So when we speak about the light, let's not always expect that light is that light through which we can see. Yes, ultraviolet and the infrared lights do exist, and you can't see through them. When those lights are present, you can't see them. Most of the times when we press a button on the remote control, that remote control is emitting some infrared radiations. Because of those radiations only, our devices respond. If you are using a TV remote, then yes, your remote can switch on, switch off the TV. So that light is working in its way, but you can't see them. So luminous intensity refers to that energy through which this sensation of vision is being enabled, right? So since it is about our perception, so again you can't say it is dependent on anything else. Sun rays are ultraviolet, sun rays are visible, sun rays are present in both the segments. So yes, it is a mixture of ultraviolet and visible. Amount of substance is something which is in the moles. So these are the 7 ones, and for all the 7s, the standard units have been accepted, and the symbols will be mostly needed for the first 5. When we speak about the dimensions of any physical quantity, we will actually mostly be concerned with the first 5 entries. I'll tell you why the remaining 2 will be of less significance, but at least everybody remember that M has to be taken as a symbol for mass, L for length, T for time, A or I for current, theta or K for temperature. At least these 5 symbols you are supposed to remember. It is too hard to understand. Occurrence of event in a sequence is time. Uh, Divit Chaturvedi, actually, the story is quite long. Abhinav, in the beginning, I told you that the notes will be shared in the chat box after the class. Okay, so just be patient. After this class is over, then you will be getting these notes through your this message communication. Share not only, sir, please. Mean, I didn't get it. Puli Jitesh, what do you want? Share not only. Share now only. Please be patient. Once class is over, we'll do that. Right now, it's there in front of your screen. You can go through it. You can take a screenshot if needed. All right. So, with these 7 fundamental quantities being accepted, now let's go on to the next part of this classification thing. The supplementary fundamental quantity. Supplementary fundamental. Now see, these are just two in numbers, 1 and 2. One we call as the plane angle and another we call as the solid angle. For plane angle, we use the symbol theta. For solid angle, we use the symbol omega. For solid angle, we use the symbol omega. No, Harshini, beta, temperature cannot be defined as the degree of hotness and coldness. If you remember, if you were there in yesterday's class, I told you that yes, few definitions would be there which might be told to you in class 9 or 10, but they were not very precise, and we will actually try to get underneath, we will try to scratch it further, and we will try to understand that how can we make our understanding better, or was there something which was little simplified. Don't you do this thing that suppose some your young brother sister who is say 5 or 6 years old, he or she comes to you and asks you some question. Now you know that you can't explain him the thing in the whole totality because he or she is too young, he can't understand all the details of them. So the same thing happens with our studies also. Till 9th and 10th, yes, we were going with many simple statements which were easier to understand, but they were not very precise. So now we will be slowly, what I can say, uncover the realities, and let's not expect that even in these 2 years we will be able to know all the truth. The process will still continue. There might be certain situations coming when still you may not be very matured enough to go with the reality. So the reality will come in parts, step by step, one by one, one by one. You can't go with all the phenomena taken together with precision and deal a situation, right? So there is a certain sequence. We start going from easy and we gradually come to the reality, and usually till coming to the reality, things become complex. Okay, so that's why there is a certain sequence in which we proceed. Go through that, be patient, let things unfold, and then make an opinion. Okay, so this quickly, don't come on to the opinion ke it is right, it is wrong, It is easy, it is hard. No, Maniket, you can't read omega as ohm. Actually, this omega here will be read as a steradian. This is the unit of the solid angle. So if I write, suppose this thing, if I say omega is equal to 4 steradian. So omega will be the symbol for the solid angle and the unit for the solid angle will be steradian. See, the symbols are less and the physical quantities are more. That's why this confusion is going to exist that a certain physical quantity, it may have the same symbol which some other physical quantity is also there. Okay. Okay. I mean to say that if you talk about the alphabet P, now P is used for momentum, sometimes we will use it for the pressure also, right? So one symbol can be interpreted for two physical quantities and the same thing will be happening. See, we have taken all the English alphabets A, B, C, D in lowercase, uppercase. Then we have taken most of the Greek alphabets, alpha, beta, gamma, delta, epsilon, zeta, eta, theta, eta, kappa, lambda, mu, nu, all of them we have taken and still we are short of alphabets. So we use them in the lower case, in the upper case. So this thing is going to happen that some symbols will be repeated and some symbols may be used for different physical quantities. This alphabet is read as omega. Now this omega can be written in the upper case like this and in the lower case omega is written like this, something like W. So this is the lower case omega, this is the upper case omega. This omega we are using for the solid angle and this omega we will be using later on for the angular velocity, right? So different symbols will be coming and sometimes they will be common. So on few occasions you may go through this confusion, but that would be a confusion in the beginning only. Very soon you will get adjusted to it. That won't be the major problem. All right. So plane angle and solid angle. See, plane angle is that angle which we have been studying so far in the geometry from class 6th or 7th, wherever you started that. So, the angle represents change in direction. The physical significance of a plane angle is that it shows some change in direction. Suppose my hand is pointed in one direction right now. I am indicating something in that corner. Now I turn my hand and I am pointing in some other direction. So you can see an angle is involved. I am rotating my hand, or if I show it vertically, if my hand is initially see totally vertical and now if I rotate my hand this side, the direction is changing. So a plane angle is the measure of the change in direction. Okay. Uh, so far, if I'm not wrong, we were measuring this plane angle with the unit of degrees. Right? For the whole circle, we said that it is a 360-degree in all. So, as per SI system, what we are doing, see, from SI system point of view, number one, there is a specific way to define the angle. All right. In general, I said that angle represents the change in the direction, but from SI system point of view, the plane angle has got a specific definition. What does it give us? It says that consider a circle. Consider a circle, make a radius, and let us call this point as A. Make one more radius, and let us call that point as B. Now, between these two radii, here is some angle and we are trying to define this angle theta. Okay, so what is the definition? Uh, the definition is in terms of the arc length between A to B and the radius. So if I say L is the arc length between A to B, I mean this curved length, not the straight line separation between A to B. I mean this curved path along which I can go from A to B. So this L I am calling as arc length, and of course r is the radius of the circle. So as per SI system, the angle is defined as arc upon radius. Okay, theta can be written as equal to L by R, and when you measure the angle through this definition, you get your angle in the unit of radians. So remember, radian is the SI system unit of angle. And if I'm not wrong, we are more familiar with degrees. 360-degree makes up one complete circle. I hope we are more comfortable with that. The term radian, some of you might have heard, some of you might not have heard. Whatever is the case, I have told you how do we define it and how do we get it in the radians. All right. So, how is the angle defined? Arc upon radius. If I go for the complete circle, let's understand it this way, that suppose if I say I take the 2 points A and B here. So now you see this is the angle theta. Let me call it theta 1. Imagine that I am shifting the point B to left. So now the B point reaches here. Now if I make the angle, you can see theta 2 is large, and correspondingly the arc length would also become bigger. So this way tell me, if the B point keeps on moving and at a point of time, if it comes and coincides with A, if you start from A and you come back on the A for the whole circle, then can I say that for the whole circle, the arc length is equal to the circumference, right? And the result says angle is arc upon radius. So arc becomes circumference and circumference by radius. So for the whole circle, the circumference will be 2 pi r divided by the radius r. So we get this as 2 pi radians. So for the whole circle, the measure of the angle in the radian system is 2 pi. And for this whole circle, earlier we have learnt that it is a 360-degree. So now I can put up a relation between degrees and the radians. 360-degree is equal to 2 pi radians. Okay, this is an important result. You have to remember it. In the beginning, whenever there will be a need for the conversion from degree to radian or radian to degree, you will have to use this. Before that, very thoroughly try to remember this result. 2 pi radian is 360-degree. So, if 2 pi radians is 360-degree, can I say 1 radian is equal to 360 upon 2 pi degree? And similarly, I can say 1 degree is equal to 2 pi by 360 radians. Now this 360 by 2 pi can be written as 180 upon pi. This can be written as pi by 180. So these are your relations for the conversion. If you have to convert something from one system to the other, you will be using this relation. For example, if I say that if theta is 60 degree, if theta is 60 degree, I want to convert it into the radians. So what should I do? See, 1 degree is equal to pi by 180 radians. Therefore, 60 degree will be equal to 60 into pi by 180 radians. Right? So 60 gets cancelled with this. You get pi by 3. So this is how we'll do the conversion. 60 degree is equal to pi by 3 radians. Okay. So time's up for today, guys. That's all. Tomorrow we will proceed with the dimensions. All right. Okay. Take care. Have a good day. Bye bye.
Good morning, everyone. Okay, so in the last class, we are discussing basics of chemistry. I gave you some questions now. Hope you tried it. So we are discussing one by one all the questions. Okay. Good morning, everyone. Okay. So in our DBP, this was our first question. Beta. Which property of an element is always a natural number? Okay. What should be the answer? Beta? Which property of an element is always a natural number? Because atomic volume, atomic weight, atomic number. Can we say atomic number of an element is always a natural number? Okay. No, no. Atomic volume can be in decimal number. It's not natural number. Okay. So atomic number is always a natural number. Done? Yes. Okay. So, beta, in the last, we will upload this new questions to you and PDF also. Okay. Or you can see the previous recording also available on our YouTube channel, which is Resonance eLearning. It is uploaded yesterday's class. If you anyone wants the notes also, we will upload in PDF form. So, class PDF beta in the last 5 minutes of the class, na, then we'll upload in the chat box. You can download it. Okay. Okay. Chalo, so next question. So this is clear now, beta. Next question. The smallest particle of matter that can part in a chemical reaction is, okay. Suppose a chemical reaction is happening. If you are reacting ki sodium is reacting with chlorine, then what will form? NaCl. It is not balanced. So which is reacting in smallest unit? Yes, atoms. Atoms are the smallest building block which can participate in a chemical reaction. Clear? Next. Example of an homogeneous mixture is homogeneous mixture. But we discussed yesterday homogeneous and heterogeneous mixture. A mixture of soil and water, the mixture of salt and sand grains, sugar solution, and none of the above. Okay? Homogeneous mixture. देखो mixture of soil and water, this is not homogeneous, but a sugar solution is always composition is same throughout the solution. Okay, the sugar solution we can say it's a homogeneous mixture of salt and sand grains will not mix up at all. So what we can say that this is also not an homogeneous mixture. Okay, next. Which of the following is not a mixture? Try it. Which of the following is not a mixture? देखो gasoline is a petroleum product, gasoline, distilled water, LPG, and iodized table salt. First thing, if I say gasoline, this is beta mixture. Gasoline is a mixture, petroleum products. Okay. Next, LPG. LPG is a mixture of na, propane and butane. It's a mixture of propane plus butane. So liquid petroleum gas is also a mixture. Next, distilled water. Distilled water means pure water without any minerals, ions, and iodized salt. Iodized salt is, we can say, beta I2 is mixed with NaCl. Okay, and we know all beta NaCl also contains some impurity like MgCl2, CaCl2. Okay, so this is also a mixture beta. Which of the following is not a mixture? We will go with B option, distilled water. Clear? Next. Which of the following is not an element? Which of the following is not an element? Okay. So H2, O2, N2. Can I say these are elemental forms? But water is a compound. Okay. These are the elemental forms beta. H2, O2, C2. They are the elemental forms. Okay. Clear? Next. The process of interconversion of solid to gas. We studied beta last class the interconversion triangle. So solid to gas directly beta without passing liquid state. Okay. So this is sublimation. Direct factual question. Sublimation. Next. Which of the following is a mixture? Which of the following is a mixture beta? Milk, common salt, sugar, CO2. Common salt, NaCl. Okay. Sugar is C12, H22, O11, CO2, carbon dioxide. They are the pure form beta. The mixture is milk. Okay. Basically, milk is a beta emulsion. It's a colloidal solution. It comes under solution, which is the mixture. Okay. Next. Out of the following example of matter which can be termed as a fluid. A fluid means which has a tendency to flow. Tendency to flow. Where intermolecular force attraction is less. A carbon exists with either in graphite form or diamond form. So this is solid. Sulfur exists in acid form, which is also solid. Phosphorus exists in P4 form, which is solid. Okay, oxygen. Oxygen exists in beta O2 form in the nature. O2. So this is a gas, so it has the highest fluidity or flow tendency beta. So we'll go with C option. Clear? Next is a form of matter that has no fixed shape but it has a fixed volume. Example of this form of matter. No fixed shape. देखो what they are talking about. No fixed shape but fixed volume. Can I say this is the unique property for a liquid? A unique property for liquid. Okay, unique property for liquid. Krypton, the elemental symbol of this krypton is Kr. It is a noble gas. Okay, krypton is a gas. Kerosene, a petroleum product, a hydrocarbon which is a liquid. Carbon steel, it's the alloy of iron, carbon, solid. Carbon dioxide, gas. Okay, carbon dioxide gas. So we will go for which option beta? B option. Okay. Next. Which of the following is not a characteristic of a solid? अच्छा solid we discussed ना बेटा high rigidity, regular shape, high density, but negligible compressibility. Negligible compressibility. Okay, so the answer is better because they are asking ki not a characteristic, not will go for high compressibility. Which state of matter show this tendency with a high compressibility? These are gases. है ना? Gases shows high compressibility. Next, this is a good question. Try it, beta. Try it. The correct order of increasing intermolecular forces of attraction in the following substances. Acha, if we compare for solid, liquid, and gas, okay, solid, liquid, and gas, then solid has the highest intermolecular force attraction, okay, then liquid, or then gas. This is the order of intermolecular force of attraction, solid, liquid, and gas. But can I say here, beta, suppose there are two different type of liquids. So which is more volatile liquid has less attraction. More volatile. What is the meaning of volatile, beta? It is easily vaporizable. It has less force attraction. So here, beta, are you finding anything which is gas? Dekho, in this option, carbon dioxide is a gas, or sugar exists in solid state, beta. Solid. Okay. 1 minute. Chalo. This is solid. Okay. Or this is gas. B option here gas. Ab acetone in water, both are liquid. Acetone in water, both are liquid. Acetone in water, they are liquid. Okay. Ab acetone in water, if they are liquid, beta, water boiling point is 100 degrees Celsius. Okay, and acetone boiling point is 56 degrees Celsius, which is having more volatility, more volatile. Less boiling point, more volatile liquid. Okay, so if more volatile liquid, then less force attraction is there. Look, we'll go for B option. Is it clear? Next. Ice floats on the surface of the water because unique question beta. Ice has very unique property, है ना? In the water there is a special type of bonding, है ना? We know, we will discuss in chemical bonding beta, hydrogen bonding. So what happens कि the volume of ice is more, so its density decreases. Okay, so ice floats on the surface of water because it is heavier than water. The density of both ice and water is the same. Ice is lighter than water. Okay, if it is having less density, then lighter than water. Clear? Next question. The property of flow of unique to fluids, which one of the following statement is correct? Okay, the property of flow is unique to fluids. So can I say only gases behave like fluid, or gases in solids? No, solids, but the solids have no tendency to flow. Okay, so gases in liquids behave like a fluid. Yes, gases has the tendency to flow, liquids has the tendency to flow. Okay, for C option. Okay, try it, but it's a good question also. Ice is floating on water in a beaker. है ना? Suppose कि we have a beaker, okay? In this beaker, beta ice is floating. है ना? Suppose this ice is floating on water. Okay? And this is label beta. Ab if ice is melting, then what will happen? Okay? If ice will melt, then what will happen? So ice is floating on water in a beaker. When ice completely melts, then the level of water in beaker decreases. Hmm. Okay.
सर होमवर्क क्वेश्चन दे रहे हैं ना वो हमको नहीं आ रहे, हम कैसा रीच होना बोले, तो हम हमको अभी पीडीएफ सेंड करेंगे, मतलब मैथ्स का और आपका फिजिक्स एंड बायोलॉजी ऐसे नहीं आता वो कल से जैसे
ओके,
मैथ्स एंड केमिस्ट्री आप सेंड करता हूँ
अभी
मतलब आपका क्लास एंडिंग में उन लोग को बोल दो क्लास एंडिंग तक करो हम कल कवर
ओके
का
ओके
वर्क दे
ओके सर, ये चैट्स भी नहीं आ रहे वो रेगुलर न्यू चैट्स?
अच्छा सर
हाँ ओके okay. So how many of you saying this? Beta, who are considering for the notes now or the questions, DBP questions. So in the today we will share in the last part of the class now. We'll share the questions, है ना? So we remain in the class. We'll share all the questions to you. Okay. Now here, if this ice will melt, then what will happen? Beta? Okay. So do you know that if ice is placed on the water, it displays the same amount, okay, which is according to its mass. So if ice will melt completely, the label will not change, beta, है ना? So the remains same. It remains same. Okay, correct, beta. C option. It remains same. Clear? Maths, chemistry also both will share beta. Just wait in the last part of the class na will share. Or from tomorrow onwards, who is preparing for NEET, for bio also, and physics will send you. Okay? Clear na? Dekho, I am again telling you, beta, ice when you are placing the ice on the surface of the water, then ice will float. The ice displays the same amount of water. Okay, so already ice is increased when ice is floating. Then ice will melt na, then there is no change of the volume. It remains the same. Next. This question better try it. Archimedes principle. Correct, correct, correct. Chalo. Tell me beta. Please do not waste more time on the chat beta. Discuss this. Matter. So matter can I match with a made of small particles? है ना? So this one solids are incompressible, so second. Okay, then solid CO2, the interparticle force attraction is low. Yes, it can convert into beta. And we have plasma. Acha, plasma is the fourth state now, so this is fourth. And gases solid CO2 dry ice beta na, so this is third. And gases intermolecular force attraction low, this is fifth. Okay, so we have to match matter. Okay, one one C. Okay, second A, this B option. Yes, B option. Correct, correct, correct. Next, the solids do not diffuse in air, beta. है ना? The diffusion, intermixing of solid particles is not happening. The particles are loosely packed in solids. Beta, loosely packed or beta closed packing is there in the solid. है ना? So they have closed packing. So can I say it's diffuse? This is true. This is true, beta. And this one is false. This one is false. So we will go for Haas. This option, assertion is true but reason is false. Okay, assertion is true but reason is false. The high diffusibility of gases is due to gases has the tendency to be intermixing. They easily get diffused. High intermolecular force attraction, high kinetic energy, restricted translatory motion upward, all the above direction. Okay, the high diffusibility of gases are having very less intermolecular force attraction, so their kinetic energy is more. Okay, kinetic energy is more. Next. Out of the following, which of the is the density state of matter? Highest density beta when there is a very close packing of the atoms is there, है ना? So solid, liquid, and gases and plasma. The densest state of matter is beta solid. Okay. Next, which has the least energetic molecules? Least energetic means intermolecular force attraction is very high. Okay, so the least energetic molecules we will say in solid state because their very strong intermolecular force attraction is present. Okay, then next, zigzag, yesterday we discussed beta zigzag movement है ना, zigzag movement of solute particles in solution is known as zigzag movement. So this is known as beta Brownian motion. Okay, this is known as Brownian motion. Clear? Brownian motion. Okay, so we are starting with the today's class. What is our today's class? Is the atomic structure. Okay, or just basic we will discuss beta, है ना? Basics of atomic structure we will discuss. Atomic structure. चलो, first beta we will discuss. If I say, है ना, the Dalton's atomic theory, any idea? Just we'll go through the theory part, है ना? Then according to our planner, we'll discuss ki what is required. This is not we are going to completely study with atomic structure. It's required the basic part of the atomic structure. Okay, basic part of atomic structure. So what I am saying, ki initial in our beta Indian philosophers, also in Greek philosophers, they gave what they suggested or they gave कि every matter is consist of है ना the smallest particle which is not further subdivided. This is said to be an atom, है ना? Then Dalton also proposed, which is known as beta Dalton's atomic theory. Dalton's atomic theory कि matter is consist of a small particle, okay, which is not further subdivided or which cannot be uncuttable and indivisible. Okay, it is indivisible. So this is atom. This is atom according to Dalton also. But when the different experiments happens beta, different experiments like can we say Faraday's uh, Faraday experiment which proved ki we can conduct the electricity in the solution. Then Julius Plucker tried to conduct the electricity in gases, है ना, in this discharge tube experiment. Okay, then discovery of electron happens beta, then discovery of proton, then discovery of neutron happens by nuclear reactions. So after these discoveries, है ना, what happened beta after these discoveries, we can say कि atom can be further subdivided. Atom can be further subdivided into fundamental particles. Okay, so I am going to write all the information regarding the fundamental particles. Like in this, if I say beta fundamental particles, fundamental particles. Fundamental particles. Okay, so these fundamental particles are electrons, okay, protons, and neutrons. Yeah, except electron, proton, and neutron, also there are particles present in the atom which are known as like positron, है ना, antiproton, but they are not the basic fundamental particles. So in our syllabus in atomic structure, we have to focus mostly on these three particles which is present inside the atom: beta, electron, proton, and neutron. Okay, so I am drawing a table. Here we will write the particle beta, the particle. Okay, then this particle, then its mass, okay, mass of the particle, then relative mass in AMU, relative mass, okay, then charge, है ना, and discovered by, and discovered by. Discovered by. So this which I am going to take beta, these are the results of the experiments, है ना? Here we have to remember as an information. Okay, so if I say the particle beta, first particle I am going to take here electron. Okay, electron mass is 9.1 into 10 power minus 31 kg. Okay, electron mass is 9.1 into 10 power minus 31 kg. Okay, relative mass in AMU, if we compare with okay, then it is 0.00054, है ना? So as compared to proton, neutron, this is negligible. Okay, charge on electron is negative, the sign will be minus 1.6 into 10 power minus 19 coulomb. Okay, 10 power minus 19 coulomb is the charge. Discovered by, so all you know ki it is discovered by J.J. Thomson. J.J. Thomson. Okay, so electron mass is 9.1 into 10 power minus 31 kg. Okay, in AMU relative mass. Acha, if I say beta the charge of electron is 1 unit, then what we can say the relative charge beta, relative charge, है ना? So relative charge we can say कि electron is having beta -1. Okay, the relative charge on one electron is -1, whose actual value is 1.6 into 10 power minus 19 coulomb. Okay, so what should be the symbol we can use beta? We can use symbol for electron E minus, okay, or E0 -1, है ना? 1 minute. Okay, here -1 and 0 means the mass of electron will take as a, as compared to proton, negligible. Second, proton symbol can be used beta P1 1 or simply P plus, or we can use H plus also. H plus also. I'll discuss why H plus I'm writing. Acha, anyone mass or of proton beta, mass of proton. So mass of proton is said to be 1.6725 into 10 power minus 27 kg. Okay, and relatively it is है ना 1 unit AMU, 1 AMU, not exactly I am writing in decimal, some places are there, no need. Okay, then charge, with the charge of proton is same as the electron, but the magnitude is same, but the sign is different beta, nature is different. Okay, 1.6 into 10 power minus 19, or it is discovered by E. Goldstein by the cathode ray tube experiment after electron, है ना? And the last is, third is after electron, proton, neutron discovery, n0 we can write, है ना? Mass of it is 1.4748 into 10 power minus 27 kg. Okay, it's also approximately 1 unit, 1 AMU. Okay, and the charge on a neutron is 0 beta, discovered by James Chadwick. Okay, so please copy it, take the screenshot of it. I'm write it down beta. Done. So why I can use H plus as a symbol of proton? Why I can use H plus as a symbol of protons? So basically if I say कि hydrogen atom है ना, here this entity, हाँ yes, hydrogen mainly of one proton or one electron or we are removing, है ना, then a electron is removed, then this has only one proton bit. So H plus is nothing but a proton. Okay, H plus is nothing but a proton. Clear? H plus is nothing but a proton. So next, okay, chalo next, what we can discuss with atomic number and atomic mass. Atomic number. Atomic number symbol is Z now beta, and atomic or mass number. Okay, mass number A. Atomic number and mass number. Okay, atomic number and mass number. Atomic number symbol Z, mass number symbol A. Ab, what is atomic number beta? So atomic number is defined as number of protons. Okay, देखो atomic number is defined as beta number of protons. Beta notes technical team will provide you. Why you are writing again है ना? Abhinav, my request कि they will provide you notes in the last part of the class. Okay, please wait. Okay, chalo focus here beta. Atomic number is what? So we can say atomic number is denoted by Z. Okay, and Z is nothing but number of protons. Number of protons. Acha, can I say it is also equals to number of electrons? Z is also equals to number of electrons. Okay, Z is equals to number of electrons in a neutral atom. In a neutral atom. In a neutral atom. Okay, so if total number of protons we are counting which is present in the nucleus, or if atom is neutron, if atom is neutral, then can I say कि total number of protons is equal to total number of electrons? That's why it is electrically neutral. So in a neutral atom, number of protons equal to number of electrons. So can I say it is valid for if ion is there? Okay, I will answer beta this question. Just wait. Why can't electron is H minus? I'll answer. No, just wait. So atom is neutral mean, what is the meaning of atom is neutral? The total charge, the net charge on the atom, okay, is 0 beta. That's why I'm saying that atom is neutral. So number of protons Z, number of electrons in any atom, in neutral atom is also Z beta. Okay, chalo. Then mass number, mass number, mass number. हाँ, mass number A. How to show A beta? A means A is nothing but number of protons plus number of protons plus number of, okay, number of protons plus number of neutrons. Okay, so A is the mass number which is number of protons and number of neutrons. Next thing, this A equals to, can I say number of protons? Can I say number of protons is always equals to Z? Can I write beta? Number of protons is always equals to Z. Okay, so this is Z plus number of neutrons and 0 number of neutrons. So what is the formula for number of neutrons counting beta? Number of neutrons is equals to, number of neutrons is equals to A minus Z. Okay, so this will become our formula to calculate number of neutrons, A minus Z. Okay, so what we learned, just listen carefully beta, कि atomic number is the number of protons, okay, or number of electrons in a neutral atom. Clear? Then mass number is due to beta nucleons. What is nucleons? In the nucleus we have two type of particles beta. Okay, in the nucleus two type of particles, protons and neutrons. Protons and neutrons, correct? So these protons and neutrons, these particles, you know, they are collectively known as nucleons. So if I say what is nucleons, nucleons are, you know, protons and neutrons collectively known as nucleons. Okay, and nucleon number, what is the meaning of nucleon number beta? Nucleon number, so nucleon number is nothing but the mass number. Okay, अब my question is atomic mass, है ना, atomic mass which we will cover in mole concept. Atomic mass of chlorine, anyone give me the data? Atomic mass of chlorine, or we can say average atomic mass of chlorine, 35.5. Okay, 35.5. Or if I say mass number of a chlorine, so you will say either 35 or 37 mass number. What is the major difference between atomic mass and mass number? What is the main difference? Okay, what is the main difference between atomic mass and mass number? Can I say this? Ki mass number means mass number, number of protons, number of protons, है ना, and number of neutrons. It is a number. But atomic mass is the weighted average, okay, of the isotopes of the given element, which is occurring in the nature beta. Okay, so this is clear. Number of neutrons is A minus Z. Okay. Next, chalo, some examples. But first, representation of an element. Representation of an element. Representation of an element. Okay, representation of an element. But in a periodic table, if any element is present, है ना, suppose this element is x, this element is x, then we will write in down beta z. Okay, or here we will write beta a, mass number and atomic number. Okay, no problem if you know, good, है ना, just listen, because we have to go according to the plan here. So representation of an element, okay, it is Z and A. Okay, Z and A, which is where Z is what beta, you know, atomic number, or A is mass number. Okay, suppose I am writing an element example ki sodium. Sodium atomic number is, if I write 11 atomic number, okay, and sodium here, if I write in 23, then it is mass number. So if I ask beta for sodium atom, what is the number of protons? Number of protons for sodium, you will say 11. Okay, mass number A, you will say 23, है ना, mass number is 23. And if I have to calculate the neutrons number, then it is 23 minus 11, so which is 12. Number of neutrons is 12. Just suppose sodium is losing an electron beta, sodium is losing an electron, so what will form beta? Na plus electron, है ना. If sodium is losing an electron, then sodium plus ion will form. Okay, अब my question is, how many protons present? How many protons present right now in Na plus? 11 na. 11. Okay, then mass number A remains 23, neutrons 12, neutrons 12, but electrons, now electrons are 10, 10 electrons because it lost one electron bit, 10 electrons. So what is the charge of nucleus? Total charge on nucleus in sodium. Total charge on nucleus of sodium is plus 11. Plus 11, magnet nature is positive, but plus 11 charge. Okay, but outside total electron charge is minus 10. Okay, minus 10. So plus 11 minus 10, what is the net charge beta? Plus 1. So net charge of sodium ion is plus 1. Okay, if I say ki what is the nuclear charge on sodium atom, then you will say, sir, nuclear is having plus 11 charge or electrons are having minus 11 charge. That's why total atom is neutral. I hope it is clear. Okay, total 11 protons, 11 electrons. Okay, na? Chalo. So pick the one. Chalo, I am giving you a question, beta, na? Take a screenshot of it. Acha, elements, first we'll write the elements, then I will give you a question. Okay, so elements in their atomic numbers, I'm going to write beta. Elements, okay, and Z value. Elements, one order wise, okay. So hydrogen, atomic number 1, okay. Acha, explain again beta which part you required. Which part you required? Nuclear charge. Okay, okay, okay. Nuclear charge, na? Listen carefully. But if I say ki this is suppose nucleus and this is nucleus, okay, in the nucleus we have proton and neutron. In the nucleus we have proton and neutron. Okay, what is the charge on neutron? 0. There is no charge on neutron. Okay, but proton has plus 1 charge. Proton has plus 1 charge. Or number of protons in any nucleus we can count with atomic number. Okay, so in the sodium number of protons are 11. Number of protons are 11. And one proton is having plus 1 charge. One proton is having plus 1 charge. So what is the total nuclear charge beta? Plus 11. The charge possessed by the total protons. Plus 11 charge. This is the meaning I am saying a total nuclear charge. Great. Chalo next. Element hydrogen, atomic beta hydrogen. Element, atomic number 1. Helium 2. Lithium 3. Beryllium 4. Boron 5. Carbon 6. Nitrogen 7. I hope all of you are aware of it. Okay. So next, oxygen, atomic number beta 8. Fluorine, atomic number 9. Neon, this is Z I am writing, neon 10. Okay, neon 10. Then sodium, atomic number 11 beta. After sodium, magnesium 12. Then aluminium 13. Silicon 14. Okay. Next. Acha, symbol is okay na? Oxygen is 8 na beta. Oxygen atomic number. O. Silicon, then phosphorus, atomic number 15, sulfur 16, chlorine, atomic number 17. Okay, then after chlorine, beta argon, noble gas, which is 18, atomic number 18. After this, potassium 19, calcium 20. Okay, then scandium 21. From the scandium, we are in the periodic table D block. Okay. After scandium, beta titanium vanadium, chromium, manganese, iron, cobalt, nickel, okay. Next copper, zinc, then beta gallium, germanium, है ना? This we can go further. Okay, so atomic number of titanium is 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, okay, nickel 28, then copper 29, zinc 30, gallium 31, germanium 32. Okay, this is in sequence in periodic table. है ना? These elements are sequence in periodic table. So we have to remember the atomic number. Beta, when we learn the periodic table now, I'll give you the simple method to find all the atomic numbers if we remember the sequence in periodic table. Okay, so we'll wait till periodic table. But till now, if you are comfortable, please try to memorize this atomic number till atomic number 30 at least. Okay, we can do this easily now. चलो नेक्स्ट इज बेटा we are solving a question है ना चलो some examples I am giving you for calculation कि we have suppose Fe atomic number 26 mass number 56 okay and it is having +2 charge है ना ferrous it is ferrous okay next suppose we have uranium 92 or suppose 232 232. Can you guess the particles, all the particles better? Like number of proton, electron, neutron. Okay? Huh? No, we'll cover tomorrow beta. Protons, देखो protons here 26. Okay? Protons 26. Here electrons 26 minus 2 because 2 lost 24. Okay? Neutron is 56 minus 26 30. Correct. अच्छा uranium protons it is a neutral so 92. Mass number A is 232. Okay 232. Oxygen is 118 beta. Oxygen is not this. This is uranium. Oxygen is Og. Protons electrons हाँ electrons is 92. Neutrons. The neutrons is 232 minus 92. 232 minus 92. Neutrons 140. Okay. I am getting one answer 140. Is this correct? 140. Is it correct, beta? Yes, we have to learn beta all whole periodic table. Whole periodic table. I will help you in this. Okay. So now ISO series beta. ISO series. ISO series. What is the meaning of ISO word in chemistry? Very good if you know the whole periodic table beta. So ISO means same. Okay. If we'll discuss beta isotopes. Isotopes. Okay. So in the isotopes, the focus should be on P. Isotopes. Isotopes. What are isotopes? What are isotopes? Focus on P beta, proton. Okay. So we can say कि atoms of same element, atoms of same element, okay, atoms of same element having different mass number Okay, but same atomic number. Same atomic number. Up if they are the atoms of same element, they have the same atomic number. Beta. So Z is same, but A is different. Z same, A different isotopes. If Z same, can I say because they will have same number of protons? Same number of protons. So same number of protons, we will call it isotopes P. Example, beta 1H1, 1H2, 1H3. Okay, 1H1 is known as beta. This is the ordinary hydrogen which is known as beta protium. Protium. 1H2 is heavy hydrogen known as deuterium. Okay, and the last is 1H3 which is tritium. Tritium. Can you calculate the number of protons here? The number of protons is 1, 1 and 1. Okay. Acha, its symbol can be also used D. Deuterium symbol D or tritium symbol T. Tritium symbol is T. So 1H1, how many neutrons present in protium? How many neutrons present? Neutrons, 0. It is the only atom where no neutron present. 0. 1H2, 1H2, 1 and 1H3, 3 neutrons. So this isotopic form tritium is radioactive in nature. है ना? Unstable nucleus. Next is after isotopes, isobars. Okay, अब I am writing कि Z is different, है ना? For isobars Z is different, but A is same bit. So are you able to write the definition now? Ki elements, atoms of different elements, repeating, atoms of different elements having atomic number same, okay? Sorry, mass number same, but atomic number is different. Z is different. Example, the famous example beta, that argon, 18 argon, okay, and 40, and calcium, which is 20 calcium in 40. Okay, so argon and calcium they are isobars. Isobars. Can I take the example of the nitrogen or oxygen? Look, nitrogen and oxygen. Suppose oxygen we have atomic number 8 है and mass number 16, or nitrogen atomic number 7 and mass of this is suppose 15. Sorry, not 15. That isotope which is having 16. So mass number 16 or this, acha chlorine also, someone suggesting chlorine also. Chlorine beta atomic numbers 17. Okay, 1 minute. Acha, here can you tell me A minus Z? A minus Z remains same or different? A minus Z. For isobars, A minus Z also beta different. A minus Z is different. Okay. Next term is isotones. Isotones. Yes. Isotones. So here we will focus for N word beta. N means same number of species having same number of neutrons. Same number of neutrons. Okay. Same number of neutrons. So Z is different beta. A is different. But what should be same beta for it? Anyone? Same number of neutrons. Because neutrons calculation formula was A minus Z. Can I say कि Z's different, A different, but A minus Z same? A minus Z remains same. हाँ, A minus Z should be same. Correct beta. Examples for isotones. Isotones. Uh, Nitrogen 7, 15, and oxygen 8, 16. They are isotonic. They are isotonic. Difference 15 minus 7, 8, and 16 minus 8, 8. Okay, so they are isotonic in nature. Beta. Isotones. Can I say isotones also beta isoneutronic? This word isoneutronic. Isoneutronic. Yes, nitrogen mass is 14, but isotope of that 14 is 15 also. No? Nitrogen exists in three isotopes. है ना? 14, 15 and 16. Like carbon. Carbon exists in two isotopes. Okay, good. So isoneutronic also we can say isoneutronic. Okay, chalo one last term I want to discuss after isotones. Isoelectronic beta. Isoelectronic. Isoelectronic. Okay, so isoelectronic means isoelectronic, है ना? Same number of electrons. Same number of electrons. Same number of electrons. They are isoelectronic. Example, कि if we have suppose nitrogen, oxygen, fluorine, sodium, है ना? Magnesium, aluminium, or they are ions beta, like -3, -2, -1, Na plus, Mg plus 2, Al plus 3. What are the atomic numbers? Atomic numbers 7, 8, 9, 11, 12, 13. Beta, can you count number of electrons? Number of electrons. So number of electrons here 10, 7 plus 3, 10. Here also 10, 10. This is 10, 10 and 10. Okay. So every species is having 10 electrons. Can I say this is iso series or isoelectronic series? Same number of electrons. Okay, same number of electrons, isoelectronic. If I ask beta one last part, suppose we have argon, calcium, scandium, beta atomic number 18, okay, atomic number 20, atomic number 21. Argon is neutral, calcium is plus 2, scandium is plus 3. Are they isoelectronic? Are they isoelectronic? Are they isoelectronic? Yes, yes, because how many electrons present beta? So electron present here 18, 20 minus 2 18, 21 minus 3 18. So they are also isoelectronic. They have same number of electrons. Okay, two terms are remaining. One is isosters and isodiaphers. Next class we'll start from it. Two terms only remaining. Then we'll go for orbit and orbital part. Okay, I'm repeating. One term isosters. Okay, isosters means the same number of atoms present in these species, same number of atoms, and their total number of electrons is also same. Isosters or isodiaphers. Isodiaphers means कि their A minus 2Z remains same. Okay. uh, Electron भी H minus no बेटा देखो H minus means if we have hydrogen 1H1, how many electron is there? How many electron? We will say electron is 1. अब it is accepting one electron and H minus, H minus, okay, then how many total electrons present? Here electrons present 2. It has the charge of -1, 1 electron, but it is not the 1 electron. Hydride ion is having 2 electrons. It is isoelectronic with, okay, isoelectronic with we can say helium and lithium plus. So isodiaphers we'll discuss tomorrow. Okay, and isosters. I'm going to stop this and we'll learn next isosters and the isodiaphers, and PDF we are going to upload. Wait for that. Thank you.
Good morning, students. So, what did we learn in the previous class? Hello. Good morning. Notes. Okay. Breathe. Breathe first. See, PDFs will be sent by the end of the class. By end of my class, all the PDFs will be sent together. Okay. The notes of all the subjects will be sent together. Got it? The homeworks will be sent for now. Understood? For MPC, yes, for MPC also the notes will come because you have a single link, no? So it will be coming by the end of this class only. Got it? And homework will be sent now, right now. Okay? So I think you have got the homeworks for maths and chemistry, right? So those two homeworks will be sent now, but notes you have to stay up till the last, okay, ending of the class. So shall we get into the bio class? Kriti, what happened? Why such a big no? Homeworks have been sent now, okay? So those homeworks are to be completed and you people are to come tomorrow with the homeworks done. Got it? So yes, MPC notes will also be sent now. Okay, don't worry about that. It will be sent. Yes. Now getting into the bio class. So coming into the bio class, what exactly did we learn yesterday? We learned that in our body, we are having a circulatory system which is actually helping for the transportation of different substances like oxygen, nutrients, carbon dioxide, nitrogenous waste, metabolic waste, and hormones. There are two types of circulatory system. What are the two types of circulatory system? Open and closed. What is open circulatory system? If the circulatory system is having the blood pumping organ heart, which is pumping the blood directly into the body cavity, okay, or body sinus or hemocoel, in that particular case it is called as an open circulation. There are no blood vessels or blood capillaries which are present in open circulation. Which organisms have open circulation? Arthropoda and mollusca are having open circulation. Coming to the closed type of circulation, closed circulation is nothing but it is a type of circulation in which, now what is the problem? MPC students, you need not stay in bio class. Okay, notes will be given. Understood? Okay, and this will be the continuation. Who is this? Vaishnavi. Vaishnavi, this is the continuation. I do revise yesterday's topic, then I get into today for the flow. Understood? So I'm just revising what I taught yesterday, then we'll be getting into the today's topic. It is the continuation class, okay? వాళ్ళ నేమ్ చేయమనాలి సార్ వాళ్ళ నేమ్ చేయమని చెప్పాలి ఎంపీసీ స్టూడెంట్స్
దాంట్లో ఫిజిక్స్ కూడా యాడ్ అయ్యింది.
ఇప్పుడు పీడిఎఫ్ చేసి వాళ్ళకి పంపించి మళ్ళీ ఇంకోటి అలా అవ్వదా సార్? ఒకసారి ట్రై చేయండి, మీరు అలా ట్రై చేయండి. నేను వాళ్ళకి 10 minutes ఉండమంటాను ఎంపీసీ వాళ్ళకి, వాళ్ళకి తీసుకొని వెళ్ళు. ఓకే. Yeah, MPC students, your problem is sorted. Just stay for 5 more minutes. Just 5 more minutes. Okay, your MPC notes will come. Afterwards, you people can leave. Got it? Okay, just stay for 5 more minutes. You will get the notes. Understood? Okay, coming back to my bio students. Yes, So students, what did we learn? Closed circulatory system is in which the blood is pumped from the heart into the blood vessels and blood capillaries. That is what is called as a closed circulatory system. That is what is called as a closed circulatory system. Which organisms have closed circulatory system? The organisms like Annelida. Annelida means earthworm. So earthworm and chordata, they are having a closed circulatory system. Right? Till here we learned yesterday, and we learned that circulatory system is having three different components. What are the three different components? One is heart, the blood pumping organ. The second one is blood vessels, and the last but not the least is blood. And in today's class, we will be learning about the composition of blood. What are the various components present in the blood? So shall we get into the class? Yes. First, what is exactly blood? Blood is a specialized connective tissue. What is blood? Blood is a specialized connective tissue which is connecting throughout the body. In our body, we are having different types of tissues. You must be knowing the cell is a structural and functional unit of our body. The cells which are performing similar function come together to form tissues. Okay, in our body, in human body, I am talking particularly about human. In human body, there are four different types of tissues. What are the four different types of tissues? The very first one is epithelial tissue, connective tissue, muscular tissue, and last but not the least is the nervous tissue. Okay, what was the second one? Second one was connective tissue. Second one was connective tissue. So blood is one of the connective tissue. Connective tissue, the name itself is telling, it is just connecting different parts of our body. Okay, it is supporting the body. Understood? So this is what is called as connective tissue. So blood is nothing but a fluid connective tissue. Okay, so coming to blood, yes, MPC students, did you get the notes? Did you get the notes? So the notes have been actually sent. So once you receive the notes, you people can go. Not required forcefully into bio class. Got it? Yeah. Chalo. Now moving on to bio class. Composition of blood. What did I tell? Blood is nothing but fluid connective tissue. Fluid connective tissue. Okay. The study of blood, the study of blood is called as hematology. It is called as hematology. Okay. Next, the formation of blood, the formation of blood is called as erythropoiesis. Is called as erythropoiesis. Okay. Next, I'm giving you the introduction of blood. Got it? Okay. So, fluid connective tissue. It is nothing but a fluid connective tissue. Okay. Study of blood is called as hematology. The formation of blood is called as erythropoiesis. Okay. The formation of blood is called as erythropoiesis. Blood is having the pH of 7.4, which means it is slightly alkaline in nature. It is slightly alkaline in nature. This is what is the general introduction of blood. Okay, so what is it? I'm sorry. Okay. Uh, I'll show you, wait. I wrote here, no? Formation of blood is called as hemopoiesis. Okay, yes, erythropoiesis is nothing but the formation of RBC. Understood? Formation of RBC is erythropoiesis. Formation of all the components of blood is what is called as hemopoiesis. Okay, so what do we know about blood? Blood is nothing but a fluid connective tissue. The study of blood is called as hematology. The formation of blood is called as hemopoiesis. It is called as hemopoiesis. The blood is having a slightly alkaline pH, that is the pH of 7.4, that is the pH of 7.4. Got it? Got it? Shall we move into the composition of blood? So, coming to the composition of blood, you should be knowing that the blood is composed of plasma and formed elements. Plasma and formed elements. Now you must be having a doubt, ma'am, what is plasma? What are formed elements? So, do you know a process called as centrifugation? Centrifugation. If you give your blood for blood test, okay, what they will do, they will put a syringe, they will try to extract the blood from your body, and that syringe mein jo bhi blood hai, that blood is taken into a centrifuge tube. That blood is taken into a centrifuge tube, or it is taken into vials, okay, based on what test is supposed to be done. Okay, small tubes are there. Now, centrifugation is nothing but a process in which the blood taken into the test tube is being rotated at a very high speed. It is being rotated at very high speed. This process is what is called as centrifugation. So, there is a centrifuge or centrifuge chamber in which there are sockets. So, the blood being collected in the test tube are being put in those sockets. Then we close the chamber, put it on. When we put it on, it starts rotating at a very high speed. When it starts rotating at a very high speed, after 10 to 15 minutes based on the time required for the test, after we switch it off, then we will see that in the test tube, okay, in the test tube, you can see layers like this. Okay, and at the bottom, you will see some precipitate. At the bottom, you will see some precipitate. Okay, so what exactly is this? In the test tube, this is a colorless. This is a colorless fluid. This colorless fluid is called as serum, or you can say, okay, let us say it as plasma. This colorless fluid is called as plasma. Okay, moving on to this part. Can you see this? This is a cloudy, this is a white cloudy emulsion, white cloudy emulsion, which has components like WBC and platelets, which has components like WBC and platelets. Last, if you see at the bottom of the tube, at the bottom of the tube, there is a red colored precipitate. There is a red colored precipitate which is nothing but RBC, which is nothing but RBC. Got the point? Okay, so with this we come to know that the entire blood is composed of two different things. What are the two different components of blood? One is plasma, other one is formed elements. One is plasma and the other one is formed elements. Okay, now see. I will be showing you this in the form of a flow chart. Blood, blood is divided into two different components. One is plasma, other one is formed elements. Okay, one is plasma, other one is formed elements. Okay, Nana, yesterday your people were very active. Today I don't see anyone active. Why so? Are you there in the class? Yesterday though you were very active. Okay, so blood is having two different components, plasma and formed elements. Plasma is 50, I think this color is not attractive. है ना? It's not visible. Shall I take green? I think this will be better. Yes, this is better. 55 percentage is of plasma and formed elements is 45 percentage. Formed elements is 45 percentage. So is the compositions of both of them clear? Okay, total kul mila ke 55 plus 45, 100%. So in 100 percentage of blood, 55 percentage of blood is nothing but plasma. Remaining 45 percentage of blood is nothing but formed elements. Now, what exactly is this plasma? Plasma is alkaline. It is, oh, just a minute, viscous, viscous, straw colored fluid. It is nothing but viscous straw colored, thick, very thick. Viscous means very thick. Straw colored means not colorless. Okay, slightly whitish color, not colorless. Got it? So it is a viscous straw colored fluid. This viscous straw colored fluid is having two different components. It is having two different components. What are the two components? Water and plasma proteins. Water and plasma proteins. How much amount of water? 90 to 92 percentage of water and 6 to 8 percentage of plasma proteins are there. Got it? So if you see, the blood is having two different components, plasma and formed element. I am now particularly talking only about plasma. Understood? So plasma, what is plasma? The previous diagram, this part is what is called as plasma. How was it? Colorless, मतलब straw colored fluid. मतलब straw colored fluid. The straw colored viscous fluid, which is the component of blood, is what is called as plasma. It is having two different compositions. Okay, what are the two different compositions? Number one, majority of plasma is water. How much amount? 90 to 92 percentage is water, and very small amount of proteins is there. How much percentage? 6 to 8 percentage of proteins. Because the proteins are present in plasma, it is called as plasma proteins. It is called as plasma proteins. Okay, now in this water we are having certain plasma minerals. We are having certain plasma minerals. Okay, what are those plasma minerals? What are those plasma minerals? Those plasma minerals are Na plus, Cl minus, Mg plus 2, Ca plus 2, etc. Okay, so there are certain plasma minerals present in this water that are nothing but sodium ions. Nothing but certain ions or electrolytes are present in the plasma. What are those? Sodium, chlorine, magnesium, calcium, etc. Now moving on to plasma proteins. Now moving on to plasma proteins. There are three different types of plasma proteins. What are the three different types of plasma proteins? Number one is albumin. Number one is albumin. Number two is globulin. And last but not the least is fibrinogen. It is nothing but fibrinogen. Okay, now we should be knowing about their functions as well. Okay, now if you see, there is a condition in which your foot starts swelling. Okay, you have swelling in your foot. If you sit for a long time or if you stand for a long time, there is swelling in your foot. Okay, what exactly happens is, the condition is the water from the cells come out into the external space and gets deposited, due to which you see the swelling. Okay, this is one condition. Condition number two, in your blood, if the albumin composition goes down, if the albumin composition goes down, then also you will see accumulation of this water outside the cell, which will show inflammation. Got it? So albumin is a plasma protein which is responsible for the maintenance of maintain osmotic pressure or osmotic balance. You know osmosis, right? The movement of water from high concentration to low concentration through a semi-permeable membrane is what is called as the albumin. Yes, Aditya, I'll repeat. In our plasma, we are having certain plasma proteins. Okay, what are those plasma proteins? There are three types of plasma proteins. One is albumin, globulin, and fibrinogen. These are the three plasma proteins. What is the function of each one of them? We talking about the first one, that is albumin. Albumin is for the maintenance of the osmotic balance. Now, how much amount of water should be there in the cell? Okay, if the cell becomes heavy with water, it has to go out. This maintenance of osmotic balance is because of the protein albumin, is because of the plasma protein albumin. Got it? Got it, Aditya? Yes. Okay. Next, moving on to globulin. Okay, globulin is again of three types. Globulin is again of three types: alpha globulin, beta globulin, and gamma globulin. And gamma globulin. Okay, now out of these three types of globulin, alpha and beta globulin are responsible for transport of fats. They are responsible for transport of fats, whereas gamma globulin is nothing but, have you ever heard the term antibody? Have you ever heard the term antibody? Antibody is produced by our body to fight against the foreign particles, right? Very good. That is nothing but for the defense mechanism. So that antibody is nothing but gamma globulin. That antibody is nothing but gamma globulin. Antibody for defense mechanism. Got it? Antibody for defense mechanism is gamma globulin. Next, last but not the least, plasma protein is fibrinogen. Fibrinogen is responsible for blood coagulation. Blood coagulation, which means clotting of blood. Which means clotting of blood. Got the point? Yes. So we till now studied only about plasma. I have not yet started formed elements. Got it? So what do we know? Blood is composed of two different components. One is plasma, the other one is formed elements. Keep formed elements aside. Take on the plasma. Plasma is 55 percentage, which is having two different components, 90 to 92 percentage of water and 6 to 8 percentage of plasma protein. In the water, there are certain minerals which are present. What are those plasma minerals? Sodium, calcium, magnesium, etc. These are all the different types of yes, Aditi, you are at the right track. Okay, but you have to wait for the answer. Okay, so this plasma minerals are present in the water. Next, moving on to plasma proteins. Plasma proteins, there are of three types of plasma protein: albumin, globulin, fibrinogen. Albumin is responsible for the maintenance of the osmotic balance. Globulin, mein again, there are three types: alpha, beta, gamma. Alpha beta for the transportation of fats, gamma is responsible for the defense mechanism. So globulin major function is defense mechanism. Next, moving on to fibrinogen. Fibrinogen is responsible for the coagulation of blood or clotting of blood. That is what is the activity of fibrinogen. Got it? So this is about plasma proteins. Now, Aditi asked a question that what is the difference between plasma and serum? Okay, so if you see over here, this is all the composition of plasma, right? So if I write now, see plasma minus, okay, I am removing this blood clotting factor, that is fibrinogen, from the plasma, then whatever is remaining is called as serum. Got the point? Okay, so I will be writing it in the statement now. So plasma, plasma minus blood clotting factors, blood clotting factors is what is called as factors is what is called as serum. Aditi, did you get your answer or there is still any confusion? Did you get your answer, Nana? Okay, so what did I do? Nandita, thank you, but could you recall plasma? It's a bit confusing. I mean their functions. Okay. I'll tell you one thing, no, I myself repeat a topic for 2 to 3 times. By the time I end the composition of blood, no, already this will be repeated. But for you, I'm repeating it once again. Nandita, listen, keep your mind very clear. Blood may, there are two components. What are the components? Number one is plasma, which is 55 percentage. Number two is formed elements, which is 45 percentage. Keep formed elements aside. In the plasma, what is there? Only two components. How much? Water is 92 percentage and formed elements, no, sorry, plasma proteins is 6 to 8 percentage. Okay, water may, there are certain minerals. There are certain minerals in our blood, right? Where are they present? They are present in the plasma ka water. Okay, what are those minerals? Sodium, chlorine, magnesium, calcium, etc. are the minerals present in the plasma. Other than water, what was there? Plasma proteins. In our blood, there are certain proteins called as plasma proteins. These plasma proteins are of three types: albumin, globulin, fibrinogen. Okay, albumin maintains the water content. Osmotic balance means it is maintaining the water content of the cell. Understood? Okay, if the cell gets more water, you know the condition. If the cell gets more water, what will do? It will become, it will swell. If the cell lacks water, what will happen? It will shrink, right? So it should have a good amount of water to keep itself good. Understood? So it is maintaining the osmotic balance of our body. Next, moving on to globulin. Globulin is of three types: alpha, beta, gamma. Alpha, beta will carry the fats. Gamma, it is nothing but for the defense mechanism. What is defense mechanism? Defense mechanism is nothing but if any foreign particle is entering into your body, turant your immune system will get activated and will start fighting against that mechanism. Okay, the foreign particle, that fighting against foreign particle, it will produce certain soldiers. Who are those soldiers? Antibodies. What are those antibodies? Those antibodies are nothing but globulin. Got it? Got it? Yeah. Fibrinogen is nothing but blood clotting factor. In our blood, we are having certain clotting factors. So whenever you have a cut on your hand or any part of your body, you get a wound. Understood? So when you get a wound, what will happen? Blood will continuously flow through that wound. Understood? But we need to stop it. So after 1 to 2 or 2 to 3 minutes of time, you will observe a dark reddish layer over it, right? Dark reddish layer over it, which is formed, which prevents the exit of blood. From childhood, we have been learning it is because of platelets. Yes, it is because of platelets, but platelets to get activated, the plasma should also be having the clotting factor, that is nothing but fibrinogen. That is nothing but fibrinogen. Okay, so fibrinogen is responsible for the clotting of blood. Now, out of this entire composition of plasma, if I remove fibrinogen, matlab, if I remove the blood clotting factor, whatever is remaining, what is remaining? Water and in plasma proteins, albumin and globulin. This is what is the composition of serum. Is it clear? Sanvika, did you get your answer? Did you get your answer, Nana? Okay, so shall we now move to formed elements? With this, actually, we have completed plasma. Shall we move to formed elements? Yep, sure. I will restart again that flowchart. Now I'll directly start here, right here from formed elements. Okay, how much quantity of formed elements was there? 45 percentage, right? Now, how, array. We are having three different components in formed elements. Okay, what are the three different components? You know it very well. RBs, acha. Okay, I'll not write. RBC, WBC, and platelets. Okay, these are the cells of your blood. Understood? The fluid part was plasma. The cells of your blood are nothing but formed elements. Now, can you tell me the full form of RBC and WBC? Full form of RBC and WBC. Can you tell? Now, from our childhood, we have been learning that RBC, WBC platelets. Okay, now we will be learning because we are 2 steps back from doctorate. है ना? BiPC means doctors only, no? So two steps back from our medical C, so we will be learning medical terms only. Got it? So in the formed elements, the three components are erythrocytes, leukocytes and thrombocytes. Everybody in the chat section has responded RBC means red blood cells. Have you ever heard the term red blood corpuscles? Have you ever heard the term red blood corpuscles? No? Okay. So, exactly if you come to see the full form, it is red blood corpuscles. I'll write the term over here. Red blood corpuscles. Okay, why is it called as corpuscle and not cell? When you talk about cell, in botany we will be learning about cell, what are the components of cell and everything. But for now, remember, you know it very well. A cell is having cell organelles, nucleus, mitochondria, endoplasmic reticulum, all of this are there in a cell. But when you consider corpuscle, it is not having cell organelles. Okay, cell organelles are absent. That is the reason why it is not called as cell, but it is called as corpuscle. Got it? Got it, Nana? Okay, so erythrocytes is a medical term, nothing but red blood corpuscles, nothing but red blood corpuscles. Now let us study about that in detail. First, we will learn about the shape. First, we will learn about the shape. Okay, so in shape, what is the shape? What is the shape? It is biconcave in shape. It is biconcave in shape. Biconcave means it is bulged from the surroundings. In the peripheral region, it is bulged, and in the middle, it is pressed. Okay, like our vada. Idli, dosa, vada, sambar, like our vada. Okay, so erythrocyte looks like a vada, matlab it is biconcave in shape. Okay, and it is enucleate, and it is enucleate. Remember, in case of mammals, not all blood cells of all the organisms are not having enucleate means nucleus is absent. Enucleate means nucleus is absent. Okay, now we know about its shape, where it is born. It is born in bone marrow. It is born in bone marrow. What is the process of formation of RBC called as? I think I just told you. Okay, it is nothing but formation of erythrocytes. No, it is nothing but erythropoiesis. It is nothing but erythropoiesis. Okay, let now it is born. Chalo, we know the shape, we know the structure, it is formed. Now, hemopoiesis is formation of blood. Erythropoiesis is formation of erythrocytes, that is RBC. Okay, how do they survive without a nucleus? Their composition is based upon their function. Understood? Okay. Now, if you see it over here, they are born in bone marrow. They are born in bone marrow. How are they born? They will help the kidney to release erythropoietin to release erythropoietin, which will support erythropoiesis. Got it? So, there is a hormone which is released by the kidney. What is that hormone? Erythropoietin. What will this erythropoietin do? This will produce RBCs. What is the production of RBC called as? The production of RBC is called as erythropoiesis. Is it clear? Okay. Next, if you see, okay, third point. So they are born. So coming to their lifespan, one RBC can survive for 120 days. It can survive for 120 days. Now it is born, it is surviving, obviously it has to die, right? So moving on to, it dies in spleen. It dies in spleen, and that is the reason why spleen is called as the graveyard of RBC. Why spleen is called as the graveyard of RBC. Is it clear? Okay, not liver, Nana. Spleen is something different. It is one of the lymphoid organ, okay, which is helpful for the production or maturation of the lymphocytes. What are lymphocytes? We'll be learning it. Spleen is the kidney. Graveyard means nothing. What is burial ground? Where you bury dead bodies is called as graveyard. Okay, because all the RBCs, dead RBCs are buried in the spleen. That's why spleen is called as the graveyard of RBC. Understood? Okay, so if you see over here, what is the shape? It is biconcave in shape, it is enucleate. Okay, where it is born? It is born in the bone marrow. How is it born? It is born by a kidney releases a hormone. What is that hormone? That hormone is erythropoietin. You ask me, right, Vaishnavi, how is kidney related to it? Kidney is releasing a hormone called as erythropoietin. Because of this hormone only production of RBC take place, which is called as erythropoiesis. Got it? Now it will live. It has to live. It will live for a lifespan of 120 days. After 120 days, it has to die. Where will it die? It will die in the spleen. That is the reason why spleen is called as the graveyard of RBC. Why spleen is called as the graveyard of RBC. Nana, you people, while writing notes, you write all the red blood cells notes under this only. Okay, include the fifth point under this only. Is it clear? Leave space. It's okay even if you leave space also, it's fine. Understood? Okay. Next, if you see, coming to the count, if you see 1 cubic millimeter of your blood, 1 cubic millimeter, RBC is present in maximum content. There are 5 to 5.5 million RBCs per cubic millimeter. Coming to male, male have 5 to 6, or you can say male have 4.5 to 5.5 million RBCs per cubic millimeter, whereas female has 3 to 4 million RBCs per cubic millimeter. Now, can anybody tell me why is the count of RBC less in case of females? It is because of menstrual cycle. Okay, it is because of the monthly cycles. The female is having less number of RBCs when compared to the male. This is the average count. Okay, this is the average count, 5 to 5.5 million RBCs per cubic millimeter. In male it is 4.5 to 5.5 million RBC. In female it is 3 to 4 million RBCs per cubic millimeter. Okay, next, blood has red iron containing pigment. Iron containing pigment. What is that pigment, Nana? That pigment is nothing but hemoglobin. That pigment is nothing but hemoglobin. What is the function of hemoglobin? Hemoglobin transport oxygen and carbon dioxide. The major function of hemoglobin is transportation of respiratory gases, that is nothing but the oxygen and carbon dioxide. Okay, there is a structure of hemoglobin. Okay, that all is not required at now CBC level. You will be given the details later on. Okay, the ring it is having, the structure of hemoglobin has a ring like structure called as porphyrin. This porphyrin is helpful for holding the oxygen molecules. How does it hold? I'll show you. One hemoglobin molecule can do friendship with 4 molecules of oxygen. Can carry how many molecules of oxygen? 4 molecules of oxygen. This 4 molecules of oxygen, when it is bind, it forms oxyhemoglobin. So what is it? It is nothing but oxyhemoglobin. Okay, next, hemoglobin percentage. How much on an average the hemoglobin percentage? 12 to 16 grams per 100 ml. How much? 12 to 16 grams per 100 ml. Again, in case of female, it is 11 to 12 grams per 100 ml, and in case of male it is 14 to 16 grams per 100 ml. The male will have more hemoglobin when compared to the female. Again, this is because of the menstrual cycle. Got it? Till here, these are the points about erythrocytes. Got it? Shall I repeat erythrocytes once? You should be able to learn it along with me. Chalo. Chalo, learn it. I'll repeat the entire class. Leukocytes, thrombocytes, will be learning it tomorrow. Understood? Every day, little input. But when that little input goes inside, it should fix in the brain. Understood? Now, blood is having 2 different components. What are the 2 different? Chalo, answer, because it should be interactive. You are in online mode. Interactive it should be. Blood is having 2 different components. What are the 2 different components? Plasma and formed elements. Plasma is 55 percentage. Formed element is 45 percentage. Very good. Yes, yes. This is the pace I want from you people. Okay, formed elements is 45 percentage. Plasma is again having 2 different. What is plasma? Plasma is nothing but a straw colored viscous fluid which is having 2 different components. Who is this saying? Serum. Serum is different, Nana. Serum has not entered into the image yet. Plasma is different. Serum is different. Got it? So plasma is having 2 different components, water and plasma proteins. Water, how much amount? Water is present 92 percentage with some plasma minerals. What are those minerals? Can anybody tell me what are the minerals present in the plasma? Sodium, chlorine, magnesium, calcium, etc. Very good, very good. Sodium, magnesium, calcium, chlorine are the different types of minerals which are present in the plasma. Next, moving on to the plasma proteins. How many types of plasma proteins are there? 3 types of plasma proteins are there. How much percentage? It is 6 to 8 percentage. It is 6 to 8 percentage. What are the 3 types of plasma proteins? What are the 3 types of plasma proteins? Albumin, globulin, fibrinogen. Albumin is responsible for the maintenance of osmotic balance. What is osmotic balance? Osmotic balance is nothing but it is helpful for maintenance of water content in the cell, or you can also say water content in the blood. Okay, if more water is there in the blood, blood will become very thin, right? So even it should not have more water, or it should not have less water. So it should have an optimum level. Who is maintaining that optimum level? That osmotic balance is maintained by the albumin. Moving on to the globulin. Yes, people in the chat section are mentioning the names blood colloidal osmotic pressure. I think they are the ones whom I have already deal with. Fine. Blood colloidal osmotic pressure is nothing, Nana. You remember maintenance of water balance. Okay. Now, if this is a cell, inside the cell there is water. Obviously, water will exert pressure. That is what is called as osmotic pressure. Okay. That osmotic pressure is maintained by the albumin. It is maintained by the albumin. Next, globulin is of three types: alpha, beta and gamma. Alpha and beta globulin are responsible for the transportation of fats, whereas gamma globulin is responsible for the defense mechanism. It is responsible for the defense mechanism. Moving on to the last plasma protein, that is nothing but fibrinogen. Fibrinogen is responsible for the clotting of blood. It is responsible for the clotting of blood, or the other name, medical term I told now, coagulation of blood. Okay, coagulation of blood. Now if you see under the entire composition of plasma, from plasma if I remove this fibrinogen or the blood clotting factor, whatever is remaining is what is called as serum. It is what is called as a serum. With this we completed plasma. Moving on to the next one, that is formed elements. 45% as we know, formed elements is having three different components: erythrocytes, leukocytes and thrombocytes. Okay, those are nothing but another name for RBC, WBC and platelets. Today we learned only about RBCs or red blood corpuscles First, we should be coming in an order so that we don't forget any content about it. How is the shape? Shape is biconcave in shape. Is the nucleus there? No, so it is enucleate. So it is enucleate. Point to be remembered, enucleate RBC is present only in mammals. In mammals, what are mammals? Milk producing animals are called as mammals. Understood? Where is the RBC born? We know the shape. Now we should know where it is born. It is born in the bone marrow. It is born in the bone marrow. By which process? By the process of erythropoiesis. By the process of erythropoiesis. Who is doing erythropoiesis? Kidney produces a hormone called as erythropoietin, which will help in the erythropoiesis. Erythropoiesis is nothing but formation of RBC. RBCs are born. How many days will it live? It will live for 120 days. Now after 120 days it has to die. Where will it die? It will die in the spleen, which is called as the graveyard of RBC. Okay, we have come to know its life cycle. Now we should know the count and number. Coming to the count, the average count is 5 to 5.5 million per cubic millimeter. In male, it is 4.5 to 5.5 million per cubic millimeter, whereas in case of female, it is 3 to 4 million per cubic millimeter. Why in female less count? Because of the menstrual cycle. Because of the menstrual cycle. Now, this RBC is having a red colored iron containing pigment, which is called as hemoglobin. Because of hemoglobin, our blood is red in color. I told you yesterday, octopus, because it is having hemocyanin, the blood of octopus is blue in color, right? But in us, we are having the pigment hemoglobin, due to which our blood is red in color. Okay, so what is the function of this hemoglobin? Transport respiratory gases. Transport respiratory gases. What are those respiratory gases? Nothing but oxygen and carbon dioxide. One hemoglobin can do friendship with how many molecules of oxygen? One hemoglobin can do friendship with 4 molecules of oxygen. What amount of hemoglobin? When you go for a blood test, they do a HB test, right? So what is that HB? How much amount it should be? It should be on an average 12 to 16 milligrams. No, not grams. Array. Wait. 12 to 16 per cubic, sorry, 12 to 16 grams per 100 ml, milligrams per 100 ml, milligrams per 100 ml. In case of male, it is 11 to 12 milligrams per 100 ml, and in case of male, it is 14 to 16 milligrams per 100 ml, and in case of female, it is 11 to 12 milligrams per cubic per 100 ml, right? Why in case of female it is less? It is less in case of female because again of the menstrual cycle. Just a sec, just a sec. What are the doubts? Ma'am, could you step aside and show the slides for me to take a screenshot? Why you don't want notes? Abhishek, you don't want notes? Notes will be sent. First RBC is formed in the yolk sac. Yes, it is actually. It is formed in the yolk sac, but here we are talking about the adult stages. Okay, we are not talking at all about the embryonic stage. How it is started, we don't talk about it. Understood? Basically, in me, it will be developed from bone marrow. Got it? And what else? Are you people having any doubts? If you have, then do clarify. Where is spleen located in our body? It is located in the mid region. Understood? It is located in the mid region near the liver. Middle part of our body. What are the four types of tissues in humans? Epithelial tissue, muscular tissue, connective tissue, and nervous tissue. Spleen is filled. Spleen is not filled. It will produce it. Acha. No. Worn out RBCs, when they die in the spleen, okay, they will definitely be eliminated in some or the other way that we will learn in next part. Okay. Why is Donan's membrane permeable for iron? Donan's membrane, see, permeability of it is only showing permeability for only specific ions. Got it? Okay. So why is it so? I'll tell you in tomorrow's class. Donan's membrane. You people come up with new words. I'm glad to see you with such a vast knowledge. So, in tomorrow's class, we will be learning about leukocytes and thrombocytes. Is it clear? Yes, is it clear? So, with that, blood will be completed. After that, I will be teaching you a very interesting topic, blood grouping. After tomorrow, we complete the composition of blood. We'll be moving on to the blood grouping. Okay, last tissue, can you repeat once? Last, I'll tell again the 4 points, okay? 4 tissues: epithelial, connective, muscular, nervous tissue. Got it? So, what are you people waiting for? Facts. Okay. Aishwarya, if your hemoglobin count goes 6 and all, no, your body will get very weak. Very weak. Understood? So eat more beetroot, carrot, okay, have ABC juice, jaggery. This will help, dates. This will all help in maintaining your blood. Every day eat a bite. Now everything comes in bites, no? So eat a bite of jaggery every day. That will help you maintain your iron content of your body. Ultimately, RBC will be maintained. Okay, yes. Now moving on to camel, why it is having biconvex RBC, I will be telling you tomorrow. But before that, let me go with the fact of the day. Coming to the fact of the day, notes will be sent. You people stay in the class only for notes or what? It will be sent, Nana. Okay, so coming to the fact of the day, do you people know about pink dolphin? Do you people know about pink dolphin? No? Yes. So do you know about dolphins? Dolphins, where are they present? Dolphins are usually present in oceans, in water. Arey, which water? Marine water, right? So dolphins are usually present in marine water, but these pink dolphins, they are present in fresh water. Fresh water means they are present in river water. Do you know about Amazon River? Amazon River. This Amazon River flows from Brazil, Peru, etc. countries. Okay, so this pink dolphin can be seen in the Amazon rivers. Okay, coming to the facts about pink dolphin, pink dolphins are pink in color not because of any pigment. If you come to know about flamingo, you know, a bird pink in color. The pink color flamingo is because of the pigment carotenoids, but there is no such pigment in case of pink dolphins. In case of pink dolphin, the pink dolphin is because of the blood vessels which are present in the superficial layers of the skin. Because of the exposed blood vessels, that is the reason why pink dolphins appear to be pink in color. Pink dolphins are having small eyes, but their eyesight is very good. They are communicating with each other with echolocation. Okay, means you know no ultrasound, so they communicate with each other in echolocation. Usually dolphins want to stay in groups, but pink dolphins are the ones which love to stay alone or in very small groups, but not in large groups. Pink dolphins love to stay alone. Pink dolphins have a long beak which is usually helpful for catching fishes. It eats fishes, small crabs, etc. So it is useful for catching those fishes. Remember, pink dolphin is okay. When we human beings, when we blush, what happens? We turn pink in color, right? Same is the case with pink dolphins as well. So pink dolphins, they are also having, when they get overexcited, they turn pinkish in color. They are born gray, but when they are growing older and older, then they turn pinkish in color. The adult male is more pink in color because of the scar tissue, because it usually fights with each other, no? While playing, it tries to fight. Because of that, the adult dolphins are more pink in color. Okay, and one more thing, yes, somebody is telling Sanvika, yes. So usually the neck is fused in case of usual dolphins, but in pink dolphin, the neck is not fused. It can rotate its neck. It is having a flexible neck. So are these facts about pink dolphin clear? The ones who did not know about it, now you know. It lives in Amazon water, Amazon river water from Brazil, Peru, etc. Okay, it is because the Amazon river water is flowing from 5 countries. So Brazil, Peru are one of them. So it flows through them. And usually all of them are marine, but this is present in fresh water. It is having a flexible neck. It communicates through echolocation, small eyes, but very good eyesight, communicates through echolocation. Point to be noted, the pink color is because of nothing but the blood vessels which are present in the superficial layers. When the water temperature changes, if suppose the water temperature becomes warm, then the blood circulation will increase. When the blood circulation will increase, no, the color of the dolphin will go more and more pink. If it is playing, if it is getting excited, then also blood circulation will increase. Automatically, it will turn more and more pink in color. Okay? Are they wild animals like not friendly? No, 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 nothing like that. Nothing. They are solitary. They don't be with themselves only. Why will they fight with us? They are not wild. Okay. Okay, students, thank you. The notes will be shared. Do complete the notes. Tomorrow we'll be getting back again with the leukocytes and thrombocytes and the composition of the blood. Thank you, students. That's it for the day. MPC PDF, it is already being sent. You check up in the chat section, Nana. Karthik. Check in the chat section, MPC students. Thank you, students.